Ну что, привет, Лужники. Да, мы начинаем этот трек хоть чуть попозже. Вот, сегодня трек по дате. Это мой тематический трек. Очень рад, что вы все пришли. Примерно в 3 раза больше людей на первый доклад, чем в прошлом году. Это приятно. Вот, надеюсь, дальше лучше. Вот, сегодня у нас...
I hope now it is going to get better. Today we are going to listen to a number of Dmitras and then Zhenya, but it is kind of funny. We have a whole track of Dimas, so I hope that you stay until the end. And the first Dima to speak is Dima Marushkin from Ozon FinTech. And he's going to talk about how they did the analytics of security. And over to you. Hi, everyone. I am going to have a very light warm-up presentation so that you guys warm up. We are going to talk about Superset and Trino for analytics and cybersecurity. And let me show who I am. I'm head of product safety at Ozon FinTech. I make Ozon's products safer, and I do what I can in terms of analytics for our services so that they're more convenient and we could focus on the issues that are the most urgent. Before I did the same in Yandex, Avito, and Positive. So now, what are we going to talk about today? We will look at different levels of security analytics that I have split from the light one to the super hell. Then we'll look at our first dash in super the sets a dashboard, and we'll see how quick it is, how exciting it is, how much it can help you to have a secure life. And then we'll have an immersion in Trino, what kind of beast it is, how you cook it, and how it can help us with the fast data analytics. And then we will collect some security cases that flew through us and that we can handle with the structure. What we are not talking about today, guys, because it is a warm-up, we are not talking about big data, no high load, no access, and redundancies, because the next speakers will talk about that. We will not talk about the stuff that comes with Trino, and a lot of smart guys will talk about that. I will talk about a very utilitarian approach to instruments. We are not going to compare the instruments, the tools. Probably we will just have a look at what's better, what's worse. So if you are a security and you want to get into the topic, this is the right place to be. But if you are a hardcore data engineer, probably you are in the wrong place. A disclaimer, all the examples are fictitious, any coincidences are accidental. If anything seems similar to you, that's a mere coincidence, and everything is hyper-utilitarian. We cut corners as much as possible, and it might seem to you that probably you don't want to cut them, and it can burn for you. And sorry if we hurt you. And memes are intentionally unfunny, unless you are really savvy. So let's get started. Today we have a playful vibe, and in our game with the security analyst, there are 3 levels of difficulty. The latest one is for the babies, and we will look at where is the approach starts, how do people grow, and how it all comes about in the story, and how then we move to the next aggregate stage. That was the level of can I play dirty, and most of talking will be about the middle level, but then from the initial level, we'll go to the element where we will look at the data analytics of a big enterprise. We'll see where it hurts and where it is really expensive, and then we'll see where the tasks are not so huge and intimidating. Like I said, we'll start with the light mode. So we start with the initial level, and our character starts with a small organization, and there are several business services with their own dashboards and services, and nothing is connected to anything, and the metrics of state are not around, and they're not even on the horizon. We just want to keep this business going, surviving. We don't have any money, so it's a hodgepodge of different business systems with their own UIs, dashboards, and admins. And our character has a lot of charisma and good Excel skills. And once a quarter, they approach different units and admins, and they look for the data which they put together in gigantic Excel spreadsheets, so as to make that all into a beautiful dashboard and somehow to then show it to their bosses. And as the complexity increases, they add some more convenient things within their competences. They help us in Excel, in Python, so that we get something faster from the admin of the system, and so that it looks a little bit nice and neater. So it still hurts a lot, and it doesn't look healthy. So this is why our character has issues in life, like they have a boss who wants more and more analytics, and it is getting harder and harder to get the huge reports when they get a query in the night, and they have to pass on their sleep and work overnight a lot. You are all familiar with that. Some of the data that we're getting from the systems get at different times. So some download happens in the morning, the other one in the evening, and then the next one probably was dropped altogether because somebody was on vacation, or the system was down, and then we have to add something to it so that the ultimate report looks truthful, and the Bass factor for this person is maximal. They are the only person who knows how to put together those Excel spreadsheets and submit them to their boss. And this is yet another factor that loses them. The bonuses and also their lives, because it's not good when everything is pegged to one single person. It all looks unmodern, the graphics are poor, and it's the retro setting of the 2000s when we didn't have any tools at all. So we are still on this level sometimes, but we don't want to stay there. And then let's move forward. Now that we understood the simplest options, now let's move on to the hell mode. So what is a hell mode? That's when we get into a huge big tech enterprise where it looks similar to Vodvasa or Botvasa and Funk, similar to what we get in a game. From the very start, the business generates huge amounts of data. We want to make balanced decisions based on this data, and we also have from the start the systems that are using good enterprise solutions, which were bought at some point, and now a whole bunch of engineers are supporting them that have the new ETLs, and they support them end to end. We also have lots of raw data, which then goes to our data warehouse, and we have lots of pipelines which prepare the data store for us, which then are presented to the top management and product systems, on the basis of which the balanced well-considered decisions are made. The resources are infinite, and you can just amazed at how many people, resources, bioengineering is supporting this mechanism, how many esoteric practices are used to keep it going and together. And this is the basic issue. That's where we start. The pipelines start falling apart, and somebody changed the field because there was probably a typo and the whole pipeline fell apart. Then the system that was supposed to provide the data during the night and all the pipelines that you wanted to put together were resisting. Everything is generated, and the pipelines are generated like a lot. And it's like in the old game where you had to catch all the eggs in the game, and the data gets in place at different times. So it's the same issue. And we have the same issue. The data arrives at different times because the pipeline gets to them at different times. Sometimes the data comes with a stream. Sometimes we get delays in the data pipeline, and it is hard to have in those data storefronts the consistency of what is born in our dashboards. The money runs out all the time because we have a lot of data, and we also have the data in the initial business system, then in the data warehouse, as well as in the data store. And so as a result, the data is replicated once or twice, and one and the same status can be kept up to 10 times in different parts of our domain. There are lots of engineers who are moving these things from one bucket to another. It's extremely expensive. And the data lake turns into a swamp. And the data that was there initially is really hard to somehow allocate by who wants them, who prepares them, and how reliable is the data. And probably no one has used the data for a year. And we see that VPS is slowing down, and we need more and more resources, and this whole structure lags behind, and it can not be done in a day, and so somehow putting all of those things together to sync them is not always possible. So when you look again at one more pipeline out of hell, we close down this level, and then again we go to the main menu.
Чего? Средний уровень.
So the middle level, what it means is that we were already bored at the basic level, and it really hurt on the hell mode. So let's have a look at whether we can cut corners somehow and stop suffering after all. So, to begin with, this is the soundtrack with the next level. So if you have something playing in your head, then that's cool. That's what I wanted. And it is a medium-sized company, and we're trying to speedrun the security part. And the security means that we don't have a lot of data. In almost all the systems, the data can be fit into one host, one operational memory, and we don't have to think about distributing the workload probably everywhere, apart from the product logs and CM with the security events. And all the logs are in the ClickHouses and Elastics, and somebody is making sure that we can interact with them. Everything else, all the events are in the CM, and we want to make sure that the data, which is quite compact, we can use our own data warehouse. We already have the data engineers who are working on the product stores in an adult way. But as a security, we will keep an eye on them. And that's it. We don't really want to get into the backlog because a task can get stuck there. And probably it doesn't look like a priority. And so we don't want to suffer over it. So we are about making this world a safer place rather than operate on a large DWH. We have some money, but not a lot. And so what happened is that they had
Есть проблема у этого ПО с тем,
And
что очень
the
низкое
issue
в
is
интерфейсе
that
самой Доджи, когда она поживет с вами полгодика или годик.
so if you work with this for 6 or 12 months, you will get used to that. So it's not about migrating with it, but we can stop using it just as interfaces for everyday work and analytics about what's good, what's bad. And
Какие уязвимости новые появляются
they
в
want
пайплайнах и насколько эти
what we
уязвимости
see
дальше в
is
процессе
that
соответствия
there are AppSec tools, antiviruses, IDM, GLP scanners, and inventory checking. So the main idea is to make sure that we can handle everything that comes there. And then how do we draw this dash? And we have
Он
good
по
big
независящим от
tools
нас причинам
like
больше
Tableau.
недоступен. Помянем.
And it's no longer available, so we can just remember it, and then we can move to looking at the tools that are available to us, like open source Grafana, which helps us with drawing something in graphs, and it's about time series data and small spreadsheets that we can have in our room on our display, and we can see whether our systems are alive. It's a good thing, and we have not chosen it.
И аналитиками, и посмотрели, что они для таких задач
We looked at that with our data scientists and analysts, and the superset works for them because it is open source and all the functionality is a default one for all the similar systems. And we have a cool thing there, and there is a certain editor where you could look at the scheme of data that you're using to select some data and to understand what you're working with, what you are dealing with, to put together the necessary data set the way you would do in Excel or some debeaver when you're trying to put it all together. And then at the end of the day, have the result in the chart, and then in the dashboard where it will all be available. And so we are looking at how it all works. And now there is the target system that we want to use, and there is the solution that we have selected. And let's see how we can make sure that this data from our database gets into our superset. Our DWH engineers are telling us it's nothing. We're just loading your data into DWH, then we make a data store with a superset, and then you move it, or no, you move it from DWH, you move it to the click, and then you move it to the superset. And it somehow reminds us of the initial previous level where we suffered a lot. So let's try to throw all of those things away, and let's
Postgres
try to have this data warehoused directly in the superset, we can use the select to get everything we need. And in our case, we don't really have the need for the operational way.
Ближе к делу, поднимаем.
Okay, so let's get closer to it. So we'll take the superset. In order to speedrun it, we can take a Docker. We put it up on the virtual base. We'll get in as default credentials. Maybe we'll remember at this point that we have to change them, and maybe not. Well, who knows?
Быстренько добавляем в
In any event, we will add
те базы данных, до которых мы как
our connections and the database that we can reach to, as far as security people can reach to them.
еще много чего.
Okay.
Дальше посмотрим.
It's Dojo, and we'll look later on which basks we have there.
Собственно, добавили базу. Она
So basically, we added up the database. We have it now.
в SQL редакторе. Прямо в
It's right there in SQL
это
editor right now. You can see it in the superset interface,
есть.
and we can click and see which tables we have in the base. Are there any delicious morsels, and how do we work with these tables in order to understand what it is that we need? All right, so if you have any SQL practice, at least if you started it at the university, you will click the correct selection perhaps in minutes or perhaps in hours. So these selected items will become a table. We save this table as a data set in the terminology of superset. And then on the basis of data set, that is to say, on the basis of the tables that we've chosen and selected, we prepare a chart. It's either a pie chart or a table or a graph. Well, this is something that we will need later on.
В общем, насобирали табличку, сделали пару чартов на базе.
Okay, so we have the table, we have a few charts.
Дашу получили как управляющий отчетик для
We have some
в данном случае. В нем вывели
report,
ребятам весь список того,
okay,
что им нужно.
that we need to provide. So we gave to our guys the set of things they have to check, and the guys have a few buttons with some click actions that are responsible for different
прямо по базовому описанию.
insecurities, right? Vulnerabilities, rather, so that if they have a vulnerability of sorts, they can
где мы свайпаем
pretty much
и это уязвимость
get rid of it with one click. Just like in a Tinder,
можем посмотреть
if you will.
графички того, сколько у нас было у кого.
So we can look at the charts and see
Можем посмотреть, как
who had how many vulnerabilities. We can see the general workload.
интерфейса Daji в
But basically, we stepped away from the Dojo interface
Daji и API.
into Dojo base.
Ребятам как
So
машинерию
the Dojo
приема отчетов от Skype.
basically is left to our guys to provide some reports from the scanners.
Отсеки довольны.
This was level 1. Okay, everybody was good, everybody was happy.
На втором уровне
So now we switch to the second level.
у нас задачка сделать dash.
So on the second level, our task
которая
was to create a dash on the vulnerabilities which perhaps present the most problem
есть
for us.
есть
The vulnerabilities which have POC, which have some keywords in their description.
быть какие-то тренды
Maybe, just maybe, there are some trends
тренды, по которым эти уязвимости
in that
для нас
trends and vulnerabilities, that is to say, which make these vulnerabilities important to us. So we have 3 databases.
База флита. Флит — это некоторая
The Fleet database.
хостов, которые
So Fleet is infra host compiler that puts together all the data that shows us what is moving in our environment. We have a deep track as the source of data for external components and external dependencies from the product services. And there is a CVE database which we are updating all the time, and it has a larger info about vulnerabilities. It's distributed on different layers. It has more detailed description. That is to say, this is something that gives us food for thought and food for work. So everything is all kind of connected. We want to bring it all into Superset, to merge it into Superset and to filter it out. Well, Superset by itself cannot do it. It dashes work based on different data sets, separate data sets. So it cannot rather by itself connect to data sets automatically. Okay, so we Googled it, and we saw that this problem actually can be resolved by Trino. Trino. Yeah, so what is Trino? What kind of a beast is that? Okay. Okay, next slide, please. So Trino is an SQL drive that, on the one hand, can be connected to data sources of different type that are supporting GBC connection. That is to say, something that can give us data in a tableized form with some kind of metrics. It supports a great source of different sources, a great number of sources, and I haven't seen all of them myself, but everything that I had to work with usually had what we need. Now, on the other hand, Trino gives the final data to us. How is this done? We are sending a query. The query goes to Trino coordinator, that is to say, to its planning center. There is a query planner that sends them to a specific DB, then it brings the data from those, brings the raw data on the worker level. Worker is a different entity. Worker connects queries from different systems and on its side joins them together if it's logical that we should have them together, and basically provides to us the final data set, the resulting data set in a table format, as if we were requesting this specific data in that specific format. So all the details, all the types of data, of clicks, of SQL requests and so on, all of these formats are in Trino. It's under its hood. And for us, this is the basic SQL that we join to different catalogs and to different sources. So basically treat them as different separate tables of one unified database. So this is a great option. Looks like a workable plan. So we add Trino as an intermediary link to our kind of path of delivering data to Superset. Trino doesn't actually store anything. It receives data in real time, it calculates, and it gives its result to the Superset. So everything that passes through Trino is done online as caches, as kind of momentary storage, and we can really utilize very few resources in order to support this Superset-Trino construction within some feasible budget. If we talk about the base variant, it's very easy to do. We bring it to Docker and the same virtual management that Superset used to be on. We add on some configs to the databases that we want to use.
ну, тривиальные настолько же, насколько
The configs are as trivial as
суперсети отдельных источников.
they were trivial when they were added to superset as separate sources. Host address, credentials, and that's it,
А
pretty much.
источники в последующем схеме отдаваемой Трина.
Now, the sources in the system later on are named according to the file names in the connections. So Dodge defect
по имени файлика defect Dodge properties,
will
которые
then
мы
be
положили на старте.
accessible named as the file name. There is a
Чтобы
special peculiarity here. In order to connect to a new source, we have to restart our host
на лету он
with Trino.
не подхватится.
It won't do it automatically. Yeah. I mean, there are
Но мы у себя нам
options, there are rather variations of Trino which can do it automatically, but it's not
подкладываем.
such a big deal. It works 99% of the
Дальше в
time.
суперсете появляется,
Then
добавляем источник.
in the superset,
Из коробки
we add a source to the superset. The Trino in the box is supported by the superset, and in
каталогов,
SQL lab we see the name of the list of catalogs,
таблиц.
and in those catalogs we see the database tables which we can work with.
Собираем себе селектик, в котором
So we put together a selected group
ЦВЕхи, которые нам известны в
which
нашем периметре.
we
ЦВЕхи из дептрека, это ЦВЕхи из
which we use, which we know on our perimeter. This is from the fleet,
и пересекаем их с датасетом с расширенным
and we cross them with the
по
dataset of
которой мы будем
enlarged
фильтровать то,
info,
что выглядит как критичное.
from which we will filter out everything that looks critical to us.
Собирали дашек,
All right, so
выглядит
we're
пристойно.
done
Дашек
with the
мы
dash. The
собирали
dash looks good.
альерты, чтобы наши инфроперы,
We also put
безопасники
some alerts into
узнавали о
it so
новых
that
селектах,
our
помнят,
info
когда
security
новый
guys
периметр появляется.
will learn about the vulnerabilities as soon as they appear in the
Чатик,
perimeter,
в Телеграме пишет,
rather
что
than when a certain chat in Telegram
Вот.
tells the whole wide world that this vulnerability was used in order to get into your assets. Okay, so
на свой вкус,
we do the triage.
нам кажется,
According to our taste, we choose issues which we think are problematic and leave things that we think can be
безопасник, вы знаете, большая часть этих ЦВЕ
can be put aside.
и очень небольшое количество.
Well, as you know, that a lot of these go into trash, and very few really go to the kind of to the doctor's table, so to speak, and are taken care
Третий
of.
уровень.
Level 3.
У нас есть зацепленная база IDM с ролями пользователя.
So we have the IDM base with
себе зацепить, чтобы делать какую-то аналитику.
roles of users.
И
We have some analytical base, and when we check the access rights, the guys say, well, okay, well, maybe we should check to what extent the department and the users really use their roles and their access rights. How needed are they for their work? Okay, they have requested that, true. Maybe they just requested them kind of, you know, on a rainy day, and they don't use them in their everyday work. Maybe. But let's check this hypothesis. Let's try to put together some roles and departments, look at their roles, look at their access rights, look at their permissions, look at their critical operations that they might use. The data is not very big. Everything, again, is in Trino. For now, we don't have information about which department does what and uses what. This thing is here in app logs, which has login, name of an operation that the user engages at a certain moment of time, and we try to cross this data. And we we can't do it.
Начинаем разбираться, что не так,
Huh? Okay, why?
в который мы подняли только что на виртуалке.
Trino, okay, which was
Датасет из клика.
uploaded to our virtual measurement, did not
А логов много.
basically did not become part of the data set because of a click. There are too many logins, and the basic virtual VM system basically doesn't hold it on. So we can draw some conclusions about the limitations of this construct. Okay, so using Trino, we cannot merge several data sets. Not merge, but rather cross, because in its basic config, which was free, open source, right, it is not possible, because these two big data sets have to be placed into the worker. That is to say, we cannot cross a small data set with a big data set. In order to give us a unified big data set, it will not have space in the intermediary SQL engine that we're using. The Trino will shut down basically due to lack of memory, due to lack of disk space, if we configure it disk-wise, so to speak. But there is a way to basically multiply workers and count them on a big cluster, but we don't want to do that because it kind of moves us closer to this very precarious condition when we played around the hard drives. But there is a way to optimize the queries to our data sets in order to, first of all, get some small amount of data, and secondly, to bring up the small data sets that we had in this example, that is the list of rows and login information and credentials, to bring it up to the big data source and to basically make all the calculations over there. So the small data set will migrate to ClickHouse. The log and credentials tables will be right there, so that it will come back to us from there. And as a resulting piece of information, it will be small, and we'll be able to calculate all the info we need. Sometimes, in order to make this push down possible, we have to help our optimizer. The optimizer sometimes doesn't do it automatically, so we have to instruct it to take the dataset X and to send it to the second system. So then we'll do a better job of it. Okay. So the final construct is a dataset from Steph and IDM, sending the result to the logs, and then get from the log the segregated condition that is later on passed over to the superset. So this is a workable construct. You can look at the hit counts and then do some analytics. Okay. A few DLCs very quickly. We can count the criticality of our product services based on the kind of subject matters that they process, that finances something else. And if we have the info about the vulnerability in the Dojo, we can look at the head count of the services that demand our prioritized attention, because if the vulnerability costs more money, of course, it should be the first one to take care of. DLC2, from the CyberSex vulnerabilities, we can choose some specifics, ones which we do understand, let's say, LTE, basically too many privileges on the hosts. So this could be corrected right away as soon as we learn about the vulnerabilities, as soon as we learn about LPE, and the info about the system which has the info about the vulnerability will also have info about the jam hosts. DLP optimization. So basically this is the story which departments have data that they swap with the world. So we can look statistically at which departments have more of these relations, and we just can leave them aside, right? So that they would not push the structured data elsewhere. So we can again look at the staff and DLP and see which departments need optimization.
I believe this is all I wanted to really say. We have gone through all the storylines, and it is cheap to launch analytics in this construct. And this thing is good for those who are moving from the analytics of standalone systems and has not as yet grown to data warehouse and big structures. And it's easy to do ad hoc research because it's basic SQL, and we are not storing anything on our own. And then it's easy to measure what was good in the last quarter. And if the system doesn't have business data, then we will have to get closer to the data warehouse stories, and the overlap of data is not an issue for small resources. We can push complicated tasks to the systems which are storing big data, and we can use DWH as one of the sources, and heavy queries, heavy requests, you have to be cautious with them, and so you have to fine-tune your resources available for different accounts, and you have to choose readly servers out of the cluster so that you can calculate something. And I recommend those who want to grow from nothing this track, but those who have already grown could probably look back at what they have done. It is a Q&A time, and if you have a QR reader, then you can rate my presentation. And if you get to the questions in the online, I'm fully ready to support you in the Telegram. If you want to ask something, I'm here for you. Congratulations. Thank you.
Смотрите, у нас там есть два микрофона.
Thanks a lot to Dmitry. We have two mics here. If anyone wants to ask questions, then line up to ask questions. And okay, so you said that Superset cannot handle heterogeneous questions. Have you checked the feature with Metabase, which ensures that you can do without Trino, although with the heavy queries it will be worse. A year ago, when we chose this construct, so it was back in 2024, right, and I wasn't able to tackle this with the Superset. This is why we moved to Trino as the data aggregator. I've got to check. Probably we could do it now. It could be cheaper, so that you don't use Trino if you have really small data. Yeah, probably we could try this out. Thanks for the comment.
Не слышно.
And the tip. Thank you very much. We cannot hear you properly. Thank you for your presentation. I have this question. Am I wrong when I believe that the modern code generation will handle building the dashboards for the end users much faster and without a superset? I have the example of working with
Ребята на самом деле
our
не очень
compliance, and those guys
и
are
они
not very much into SQL, and they using ChatGPT and DeepSeek. They feed them with data. They prompt what they want to get the outcome. They get the ultimate select. Then they check it out in the SQL lab as something that is good for them, and then they use the virtual assistant. Probably at some point it will work like this, that I will give to ChatGPT or somebody, some other agent, just the scheme, and the user can use the chat to talk to the system. This is a great thing, and I would like to go into this. And what exactly do you mean? And it's not just about SQL requests, but also graphs, and generate not just SQL queries, but also probably HTML pages, something like that. And I believe that via the LM agents, we can put together the structures where we will feed the data, everything we have in our space, and then we'll have SQL, and then the superset or something else that we will have there, and this will come from the teacher, and as the result, through this combination of agents, we will have the ultimate dash that will help us with talking in a text mode with ChatGPT. This is the future that is coming soon. Talking about that, the superset, you can use the dashboards, and if the neural network can work with that, then yes, you can import those. Make some JSON and then import it to a superset. Hi, I'm Alexey Kryukov from Azbuka Vkusa, retailer, food retailer. Despite the issues that you showed, do you really regret that you didn't give it to a DWH team? And what does the DWH team say about those tools that you are using? You're taking away their workload. We are not sorry about that, because we use the upper stack for being autonomous, for being standalone. All the analytics are in our resources, and we can forecast ourselves the time in which the new analytics will happen. For me, this is the main reason why we are probably cheaply or in some other way, but we are doing it in-house. And so far, we can do without external resources. Definitely, we will grow, and we will work with those guys to keep something big. But so far, to speed runs and to address issues as they arise. For us, it is dramatically cheaper to have it in-house. And the guys in DWH, they're happy about that. We are in sync with them in their stack. It will be easy to migrate because they have the same clicks and supersets. And then going into a joint platform together won't be all that expensive.
Дим, спасибо большое.
No more questions from the floor.
Все, спасибо.
Thank you. Are you ready? The next speaker, are you ready?
Так, мы продолжаем. У нас серия докладов про Трина.
And now we are continuing.
Дима Лахович.
And so we have several
Дима расскажет
presentations about Trino. This is Dima Lachovich from the Square Meter, and he's going to speak about the Cat's House and how this operates. Okay, can you hear me? Oh, gosh. This is high tech. I don't have a clicker, though. How do I click? Without a clicker.
Как это?
Не-не-не-не, это потом. Спасибочки, спасибочки.
Thank you.
Вперед-назад, вперед-назад. Сейчас.
Now I'm going to move back and forth a little bit.
Доклад будет про среднекопытное животное. У нас просто кошка с копытами.
And we are going to talk about the
Сейчас, секунду. Можно начинать, да?
hooved animal.
Собственно, меня зовут Дима Лахович. Расскажу вам про
I am Dmitry Lakhvich. I will talk about the Cat's House data platform. Everyone has a data platform, or otherwise you can use somebody else's. Anyways, I will tell you about how we built the data platform in our company, the Square Meter, and why this is important for us, and why we are driving this, and why this is good for us, and how can we live in the world where data rules the world, and this data is easy to use. The Square Meter company is about prop tech. If you do anything with a property, you come to us. Every fifth new development is sold through us. We also work with land plots and secondary properties, and we will help you come to us. And we are a medium-sized company, and we have in our databases dozens of terabytes of data. So we have middle data, and the clicker is not there yet. And we have terabytes of data, and this defines the stack that you're working with. Because if we had more data, probably what I'm talking about wouldn't be useful. We are working with JSON, and they are JSON-like systems that come to us from microservices. Our main customers are analysts, but pretty often it is also about a partner coming to us and asking for analytics, and we tackle that. We live in Yandex Cloud. We are cloud-based, which defines the stack we are using, and we have certain prerequisites that we can reuse, and we use the data in a cloud, and we also have migration plans for the company. And for the past 6 years, we have had the data storage, which could show the data about who, what, and how much we sold. And this worked on SQL. We also had self-written tooling and IBM code, and NiFi and Airflow as ETL. Then we understood this is hard to support, hard to scale, and to a certain extent the development stopped. And what happens at a time like that? You can develop this and use a lot of resources. But when we understood that this cannot be tackled with more resources, we have to undertake certain steps, and then sweet words like migration, new platform, things like that come over. You have something old, something new, and you want to move to something new. You start building something new, but the old is still operational, and you do migration. And we are the sort of people who wanted to live in a house where we would feel comfortable, and to have more data, and to do more sell. And we don't have any choice, because we live in Russia, and for us, we have our own journey and track. We cannot really use the Western AWC-like cloud provider, so we don't have a lot of choice. And we are not a very big company.
Три варианта есть сейчас, которые
So
существуют.
implementation is not good for us. We need the plug and play.
Немножко проблемы с
So the choice is small. We have the Green Plum. The OSS version is dead. People say different things. You have to choose between Green Plum. We also will need the GBA and very specific hardware. We could also use ClickHouse. We already have it with the old storage, and a lot of people are taking it to build their data warehouse. Since we are in a prop tech, we have a lot of joints, and it is hard to build the system on a ClickHouse without the DBA, and this is about engineers. You can build excellent tools for engineers, and an ordinary user will get completely lost. And now there is another system which has been around in Russia over the past 4 years. It became viral with Databricks. We need an open format that we could use with different tools such as Green Plum, and we also need to separate the computer storages, since again we are in the cloud. We are flexible, and so we calculate everything during the night, and we are building our own database. And the Lakehouse is about the modern open spreadsheet formats, and you know a lot of others, and that's how you can use it. But these formats themselves, these formats do not provide to you the convenience. It's similar to what we did 5 years ago when everyone reinvented their own wheel, trying to make sure that it looks more like a database with the updates, inserts, deletes, etc. All of this is addressed through the Lakehouse formats. And what stories did we need with the Lakehouse formats? We needed atomic transactions, and data search is either done or is not done. You don't see interim results. If something goes wrong, you will not see rubbish data. We also need the aligned updates and scalability of the data. We should be able to respond fast to the business needs. And what are the available Lakehouse formats? If somebody knows formats 4 and 5, but what we see are just 3. Hudi, Data Lake, and Iceberg. Hudi is cool, nice, with a lot of features. It's all cool, but it doesn't really work. You have to dive into how it works. And there are a lot of handles that you can try and break. And there are a lot of tools, but it is a nice format, and they have the most features, but you have to really dive in, and you have to go to the developers and ask how to make sure that it works. The data lake is also cool and nice, but it is overcomplicated. This is data first bricks format, and for a long time they said if you are not using the Pay 4 version, there are no features. Now they turn their face to the community community. They're saying we are more open source, but anyways, this is more Databricks first format. And then there is also Iceberg, and it works right out of the box. And Iceberg was the easiest to work with, so you just plug and play. And we wanted positional deletes. For example, when you have some download to the third party, and you understand that with the third party, you understood that you have to do another download, but with somewhat changed numbers, because that's what they're asking for. And you can do a simple update and download again without rewriting the files. It's all working fine. We have selected Iceberg, and Iceberg, just as any other spreadsheet format, it has a certain structure and the types that it supports. It supports a lot of primitive types, and in the third version there are complicated things like geometry, geography, and the unknowns, and there is a complicated thing similar to a camera, but it works well in a binary format, and everything that you need to organize the hierarchy that would be hard to organize in a 10-year-old database is available there, and the format supports the evolution, and you can change the format of columns and the sequence, and if there is a client with a legacy format, they can still use it. The format itself is onion-like, so it uses I'm losing the voice. It is using Parquet and Abra in data files. There are 3 layers. There is a catalog, then a metadata layer. All the layers are important, but that's how the world works. It will not work if it's not in sync. We have data files, manifest lists, and manifest files. And in the data layer, we keep everything that we are recording and what we are deleting. And the format on the disk or the file system uses this following paradigm. You are writing the files, then you have the manifest and data files, and it grows for some time, and then you do maintenance, and you clean, the system cleans up itself what it doesn't need right now. The main idea that is responsible for metadata catalog is the manifest file, and it has a list of files that is used for keeping the data, or it contains the list of deletes that we will do. So if you have ever reinvented the wheel with Parquet or Orc, they use exactly this logic. And Iceberg supports exactly that. And you can change the fields, move them up, etc. You need it because if you have a spreadsheet, which is important for the business, you can evolve it, and the old clients will not be deleted, they will be supported. So you can keep the spreadsheet that supports the whole business. You can keep it as a core, you can update it, and you can also see what it looked like historically and what happens. So first, we identify the transaction strategy, and we have the org bucket and Terra, and then we check if everything is fine. We check the uniqueness, and we make sure that everything is fine. And we might have certain limitations in Iceberg. We create new manifests and new snapshots. And it is the state of a spreadsheet at some point in time. And then after that, we do the following. We take the metadata that we replace, and then we make a recording. If when you made an entry, somebody else was making an entry, another client will check whether the number of snapshots increased in the time that they were writing, and if it increased, they see that somebody wrote in this table. So Iceberg supports the optimistic occurrence for most cases. For the storage, it's all good.
Каталога, загружаем текущий снапшот. То есть снапшот на самом деле может быть.
Okay, so we
Устраивать time travel.
upload the snapshots. There can be lots of snapshots. Some catalogs allow you to give a general picture of all the snapshots. So we check the scheme, we read the manifest list. There's lots of statistics. It understands which manifests it needs, which it can skip. So we filter and then upload the manifest files. The manifest files also has lots of statistics that we can take, right? And then we have to use some filters. Employing these filters, so we get the data files only which we need, we decode them, and then we provide it to the client. Okay, so Iceberg catalogs. Iceberg catalogs optimize productivity, they coordinate operations. Iceberg works well with C3. If you lose Parquet, it's different. The operation can take a lot of time. Okay, so with Parquet tables, it will work much longer. It also provides the access to the tables by names, table name. So this is the function which is responsible for authorization as well. Which kind of catalogs does Iceberg have? Well, basically there is a set of 6 types: Hadoop, Hive, JDBC, REST, and Nestle. Okay, so you can write your own catalog. It can operate on its own protocols for your clients. You just have to understand that there are many of them. They all have pros and cons, and sometimes there are more cons than pros. So how does one choose a catalog? Well, this is what is happening right now. This is some kind of a gold rush, right, about the formats. There are a lot of mergers and acquisitions of companies who are doing that. So Databricks bought Tabular, and Databricks sort of is in the lake. A lot of providers like Amazon, for instance, have everything. Okay, so if you work with Amazon, you can use their catalog. If you have your own vendor, you can use your own vendor. If you migrate from the hard drives, you probably already have Hive. Take Hive and forget about it. Again, if you have a lot of time and your engineering team doesn't have a lot on their plate, take Nessie and you can basically pump it up. Okay, so which problems does Lakehouse have? As any other database, it has quite a few problems. We already dealt with these problems, so we are ready for them, right? So you don't have to go to vendor if you know the problems. It's live format, so not all drives support everything. So the practice shows that if you use one drive, everything works well. If you're using two drives, some statistics could be lost, some other things could happen. Second, the specification. Specification appears and then disappears, and what happens with it, we don't know when everything is finally implemented. Okay, we're also striving towards better catalog, but since we need maintenance all the time, and you will be doing maintenance, I assume that you will be fixing your bugs quicker, and then you will have new features appearing. By and large, every day, day by day, Iceberg is becoming better and better. New functions appear all the time. It is not a black box, unlike database, so you can take it and see what happened there. This is priceless, because if you have a black box, you can't get into it and you can't understand what was happening. All right, so now that you've chosen a format, what's next? Then we decided to build a data platform, as shown in the picture. So we've got everything except for the blocks colored in yellow. But basically, what do we have? We have Trino. We use Trino, and the previous speaker already told you about Trino. Our goal was to make it in such a way that people who are working with this platform could utilize it quickly, efficiently, and release their products quickly. We also want the job to be interesting. We also use the stack. We have Airflow, dbt, and everything is covered up by Cosmos in our case, okay? So Flopa M2.ru is Trino. Okay, we also have terabytes, not petabytes of data. Again, ours is not a very big company, so we use it both as ETL and as everything else. So basically, our superset looks at Trino, and it can display the dashboards and everything else. It works well. We don't have any requirements for super quick processing. So what do? We upgrade Trino. It lives in Yandex Cloud in Kubernetes. We use the Trino's elasticity, that is to say, we engage workers when we need them, and when we don't need them, we don't engage them, and we don't have to pay. So this all happens through the OAuth 2 providers, since we don't have to manage logins, authentication, and things like that. Do you know what Airflow is? Okay, it's cron. What is cron? So basically, when you launch the task according to a schedule, this is a standardized function. You can look it up on the web. Some people may disagree, but maybe those who disagree know more about it than I do. dbt, okay? I think you all heard about dbt. What is it? Well, again, there wasn't much time, a lot of conferences are happening right now, but basically you are giving your data engineers and system analysts a certain structure of the repository, which has a SQL code, and which you can templatize. So SQL code gives you a super graph of calculations. You don't have to do it manually. So dbt is doing all that and a lot on top of that, such as free reporting. So you can all store it in one place, and we do use that. And we'll tell you why this is important to us. Okay, so we have dbt, we have Cosmos. We have Airflow. So this is all everyday routine for a data engineer. It's not that interesting. It was interesting in 2019. Now this is routine. Anybody can do that. The lots of courses which teach you to do that. So we use our own Trino connector. We have Trino plugins for Airflow dbt. It's called Cosmos. What does it do? It takes a dbt model or models, and build you a tree of ducks that could be launched according to schedule. So it's not just one task that launches the DBT model. No, there is the whole tree, okay, the whole lineage that you can launch. And since the launch of DBT is parameterized, you can launch the same model in different environments, given in mind different drives. So you can basically, by giving a command, or rather by working around it in SQL, you have the result on the screen. So a data engineer in the morning comes, presses the clear button, it all recalculates, reanalyzes, works well. A few words about ingest. The Mongo database is the most commonly used source. So we basically bring it to our Hadoop. Then we do the dump, and there it goes. It works for a while. We have about 100 different collections every day, about 2 terabytes probably. So we store that on the hard up. We have PostgreSQL, and we write on the DBT. We add Postgre to Trino. We describe a model that allows Trino to take it and utilize it, and we can use the resources and take it all out. So basically, once every 24 hours, we download everything that we have in this service. Then we have the CDC, Kafka, and other sources. But this is the major resource that we use. This was the first task that we decided to solve. Okay. So what's the most problematic thing? The JSON. JSON is a semi-structured format. We take Mongo JSON. It has to be sparsed out. So we'll bring it up to some kind of a decent look, and we do all of this with SQL. We have to write this SQL ourselves, quite a lot, nothing to do, but we generate it quite easily. Some things will not be generated automatically. You will have to put in some manual lines, but it's okay. At the same time, you have to understand that DBT will not always generate you a table. So you will see whether it is materializing on the disk or not. Now, the platform was launched in November. By now, we've had 700 models. These are all models that business uses. What kind of layers do we have? We went into the architecture. I'm sorry, my presentation is about a bit of everything. So let's talk about the different layers and how we separated those. We have the bronze, copper. Bronze is for raw data, copper. Again, because we have to take care of JSON, so that would be clearing up or joining other stuff. So this is kind of the first, more or less, lookable layer. So it's copper and then silver. The system analysts are responsible for the silver layer. They are writing the code for consumption. And then we have the golden layer. The golden layer has the contract for the business. Okay, so once we've made it, once we've created it, we cannot change it if we want it. No, this is a contractual stuff that we have to support. So such layer separation allows you deliver the value. Each of the participants know his area of responsibility, and we can guarantee a specific quality for each layer.
Мы живем в монорепе, у нас все покрыто CI.
We live in monorep.
CI-тесты. для DBT. То есть DBT
And from there, we
как
launched the
фиксировать данные.
tests
При этом как это сделать-то?
on the DBT. The DBT allows you to test your data. How is this to be done?
При этом,
We
например,
launch
если у нас уже
CI/CD
был
tests.
у нас
For instance, when we create a new
источника
branch,
есть некоторый sample, то есть мы
we have a sample for each source.
добавляем новый источник и сразу
So
добавляем Jabу,
the
который
situation is
генерирует
typical. There is a new source.
его перекачки.
So
То есть, sample это где-то
once
просто 1%
we start
случайных
working
данных.
on it, it basically generates automatically just 1% of data on the source. So a developer does something, pushes it in its branch, and it starts CI. The CI schemes are brought over for gold, silver, copper.
Имя бранча.
So there is a branch name, let's say silver. So what we do is basically we get rid of the headache about merging something that doesn't work. I think about 95% of cases of our mistakes are taken care of CI level. Okay, so basically 5 steps to success. How is this done in the company? How do we deliver value from the point of view of business? We have a business idea, and then it goes into the number 5, into the reporting, regular reporting. But let's talk about points 3, 4, and 5. The kind of every 24 hours in data flows, we use jobs which take data from the sources. Then there are other jobs that take it from the CDC of Kafka, but let's talk about T-1 analytics. After each ingest, we have a data sample on each source. It takes quite a lot of time, because basically we have to archivize everything. We have to take into account all data, not just the first 300,000 lines. And then the Airflow launches DAGs, which gives you DBT model. So all this tree on 700 model that I mentioned is being run, and is building a model. At the same time, each model is a task in Airflow, and we can launch them task by task. Okay, so once this is built, once the regular reporting is done, you can look at it through Trino, you can look at it through DBT, documentation, then your workday starts. So the system analyst starts his morning with building up a new table. He may go to the customer, to the backend, and get info from them. But what does he do? At the end of the day, he writes an SQL code, he checks his hypothesis, he understands what he needs, and he builds a new model. So on his local notebook, he writes this model out, and he should launch this model right away and get the result in his own private space. So he doesn't have to go to a data engineer for help to get the result. He just launches an instruction or a command, authorizes himself when the prompt comes up, and the Trino cluster calculates his model, which happens rather quickly. Why does it happen quickly? Well, the DBT can monitor changes in the models that have been done recently with the defer mechanism. We have the defer master, and when the system analyst uses the local hardware, it's being detected. Okay, and he can also look up what's already there. All right, so he built it, he gave it to the business tested it, it goes into production, we do the quest, the branch runs all the tests. Some of them may fail because the system analyst may not have taken into account everything. Then review happens. Once preview is over, it goes into the production. You don't have to do anything else. You basically have a product pipeline with which you don't have to do anything. Okay, now when we have a new product, we have to develop it for about a month and a half. I think this is quite decent. Since we're building new data platforms all the time, we don't have everything in there that is in our warehouse. Whereas we have a lot of products, right? We're talking about production right away. We have lots of things on the storefront. The challenge is we have to maintain Iceberg. We have to clean CI and the user schemes because we give some level of freedom to our users. Sometimes we have to manually work with full refresh. Yep, and sometimes it can break some things, but that's okay, we fix it. If we don't do maintenance, if we don't do any of it, you'll be in trouble. Your budget will go out of proportions, everything will break down. Maintenance on the data platform, I think, is much more important than bringing in additional functions. Since we live in the Yandex cloud, we of course have to count money. Okay, not to go bankrupt, we have to use the elasticity of the system. You have to know your infrastructure. You have to understand when it works well, when it works less well, not when the jobs are dropping. So use the specifics of your Airflow, like Airflow 3, which is quite scalable. And you can use the Yandex cloud peculiarities. For instance, if you use the instance during the nighttime, it's 3 times cheaper. And SLA for data storage is not the same as the services, right? So you don't need the geo distribution. You can probably live in the same region and do with the smaller installations of clusters. Now, you have to understand that there is a certain process that you look at, and you understand what is good and what is not. For example, look whether you are using additional disks. If this is indeed the case, this is too bad because you are paying for them in the cloud, for the cloud usage. And so basically, initially, when I looked at what we're using, there were lots of disks that we were not using. I deleted them. We started saving 3,000 rubles per day. You see, the Yandex services, just any other cloud, like to give you many options that you don't really need. You have to streamline your configuration. You don't have to have 3-sharded ClearHouse. Okay, sometimes you need just one if it works well. So ClearHouse is the database for engineers, and sometimes all of your ClearHouse lives in one replica and nothing stays in the second replica. Why? Because the users don't work well with replicas. The results. So basically, we started saving about 50% once we looked at what could be changed without changing the things drastically. We just optimized the configuration. In a sense, the cloud makes you do that. If you neglect it, you pay more. All right. I mean, it's not your money. You have your own work. You have your own job, but I don't have to go up to the top floor and defend our budget, right? That's why we were able to build a new platform within the existing budget. Thank you very much. These are my contact info. For the feedback, for the contacts, please leave your feedback. Hopefully, if my presentation is the best, I'll get a bonus. But I only have about 6 minutes for questions. So basically, bottom line,
То есть
Maintenance, platform building is a process,
встаете на конвейер, смотрите,
just as in production.
долго смотрите,
You look at the
смотрите,
conveyor,
принимаете решение,
you see what's
спросите
going
физика.
on, you see your data,
И после
you
этого
decide to
смотрите,
introduce
вот
changes,
сделать лучше или хуже.
and
Если
then
хуже,
you
возвращайте
evaluate
обратно.
whether you're
Если нет,
able to make it
продолжайте
better or
стоять,
not.
смотреть,
If not, bring it
каждый
back.
раз,
If not,
что-то
keep
приносить
looking,
и так далее.
keep
Если просто
experimenting.
думать, что вот все сделал, все
If
заработает, все будет
if you
хорошо,
think that
это не
once
будет,
you've done it,
будет,
everything will work
возможно, даже
automatically,
похуже. То есть,
no, it will not.
собственно, нужно
Maybe it will work
воспитывать
even worse.
культуру в команде.
So basically,
Культура важнее,
work
чем
on your culture.
Спасибо.
Culture, I think, is more important than
Спасибо.
the skills.
Дима.
Thank you very much.
Так,
Oh,
сейчас
Dmitry,
секция
thank you.
вопросов,
Thank you.
ответов.
We have a Q&A session
В прошлый
very
раз мы
quickly.
забыли выдать подарок.
Last
«Лучший
time
вопрос», мы
we,
выдадим после
We
Диминой
forgot to
сессии.
give
Так
the
что не
prize for the
разбегайтесь, у нас
best
есть
question,
кабанчик
but
за
we
лучший
will do it
вопрос.
now. Okay, so we have a small gift for small award for the good question.
Ты слышно?
Да, да, да.
Can you hear me?
Ты
Yeah.
сказал, что у вас есть создание
All right. You
сэмпла.
mentioned
А
that
скажи,
you
как
have
решаете
sample
проблему
creation
консистентности сэмплов,
function.
или вам пофигу?
А под
How do you resolve the issue of samples consistency? What do you mean
который позволяет
То
by
есть,
that?
смотри, вот ты
We go to
тащишь
Trino, there is a SQL
SQL
function. Okay, so you bring, you take Mongo, you take several data set, several documents from Mongo.
как? Ну,
То есть
просто
забиваешь, да?
How do you,
такой задачи, на самом деле.
Ну, то есть у вас нет этой
what do you do with the
Скажем так, наша задача,
related
на самом
data?
деле,
Well, we don't have a
постоянно
task like
проверить
this.
большую
In
часть
Trino
ошибок,
doesn't
и
have
с
this
точки
problem.
зрения
It's not
связанности
that.
данных
It's
и так
that
далее,
the
не делаем
our
ничего.
task is to
Наша
check
задача, что мы
the
там
major
потеряли
kind of the
канал,
amount
как-то или еще что-то.
of
К
errors.
сожалению, ну, это был,
It is not our task to
говоря,
see whether
fast
column
win,
was lost or not.
который мы сделали, и так
It was a
далее.
fast win, which we did,
И
right?
на самом деле тут уже связанность данных проверяется DBT
And the
тестами
data
полноценными,
connectivity
если
here
уж это
is
делать. Это уже
checked by the
отдельный
DBT
процесс
tests.
именно по проверке
This is a
данных.
separate process about the
Так, еще
data
вопрос.
integrity check. Thank you very much. Any other questions?
Что вы используете
Okay, you mentioned that you are using Iceberg and
Я
Flink.
не говорил, что используете.
Flink? No, I didn't say we were using Flink.
процессинг?
Well, but some kind of processing, right?
Хранилище, и вот когда в
You use
процессинг
Iceberg and
хочется
cold storage, and
сейчас
during
данных,
processing,
вы
sometimes
в Iceberg ходите, или у вас
you
есть
have
некое
to
горячее более
bring up
хранилище,
the data.
это
Do you go to Iceberg or do you have hot storage in order to speed the things up? At the time, we don't have the hot storage. We have Iceberg tables. We have real-time dashboard, which we are piloting right now. So everything is written into Iceberg right now, and then later on, Trino aggregates that and brings it over to the superset. So we have maybe 2 or 3 minutes lag. Do you have ClickHouse? We don't. Yes, we do have ClickHouse. So right now we are determining its future fate.
Не слышно, Дим.
Все, меня я
There was an attempt. Oh, okay.
Нет,
Okay.
не время. Почему
I don't.
микрофон не
What's going on?
А включение
Your
микрофона
mic is not working. Oh, I see. I probably pressed a button.
Алло,
Could you please turn on my mic?
дай мне вот этот.
Turn my mic on. Give it to me. Okay. Hi.
Да, у нас мы
right, so once again-
пересматриваем то, как мы используем ClickHouse.
Yeah, we are rethinking the ClickHouse use right now. The ClickHouse will be the hot layer,
Сейчас он
absolutely.
есть горячий слой, но просто на нем есть
It is a
старые
hot layer right now,
ETL-процессы
but we're
старые
using the
хранилища.
old version
Вот.
right now, and we are.
уже старые
What about
Да не, у нас
Cassandra,
нет
or
таких
is
объемов
Cassandra too
данных.
old?
Нам
No, we
ClickHouse
don't have that
хватит, на самом деле,
many,
в глаза.
that much volume, so
И если мы
one
говорим
instance
о
is
Cassandra,
certainly
это
enough.
всегда какие-то
If we talk about
продукты
Cassandra,
по-хорошему, которые должны
these
приносить
are the
компании
products
или решать
which
какую-то
should
общую задачу. Ну,
bring company money or
у нас
resolve
преимущество в том, что компании среднего
a
размера,
common
и мы
task.
можем достаточно
Again,
красиво
our
вот такой
specifics is that
тренинг
we are a
построить
middle-sized
на
company, so we
Trino,
can
и
build
построить
such a wonderful, elegant system on Trino,
хорошо, и даже
based on Trino, and it will work
можно
well,
делать не T-1,
I think.
а
And
T-час. Дальше, если
I think we can do
бизнес имеет
not
потребность,
T-1, but T-1 minus
минутных задержек,
hour.
какие-то конкретно
And then
продукты,
again, and the business has
и мы
a
знаем,
need
как их
for
организовывать. У нас сильная команда
several
инженеров,
seconds
собственно,
lag.
поэтому,
legs. We know how to put this together. We have a very good team of engineers, and we can probably organize it on
Еще один
different
вопрос.
stacks.
Давайте.
Okay.
Подскажите, расскажу.
Another
Слышно?
question.
Можно погромче микрофон?
Can
Так, так
please
слышно?
talk into the mic?
Ага. Ты рассказывал про то, что в CI вы поднимаете мини-версию хранилища. Подскажи,
You said that in the ICI,
поднимаете ли
you're able
инфраструктуру
to
или
look
только
at the
этот слой?
Мини-версию хранилища занимает это 5-10 минут.
the mini version of the storage. How long does it take? It takes about 10 minutes because we use assembler. We use the same infrastructure. In the future, we will have several clusters of Trino. It needs resources. Right now, it lives in Trino, and it feels okay. But we basically will be covering it with the same click, with one.
Это вот должна быть всегда.
Yeah, and behind it there will be several clusters.
Пока это 5-10 минут CI проходит.
Ну, то
But
есть это на
referring to your
продовой
questions,
игре
about
вы
5-10
поднимаете
minutes.
еще одну мини-версию.
So using prods, but you're creating another mini version.
Собственно, таблички
Yeah, since
Superset смотрят на
the superset stables
такие витрины, на golden витрины, в которых уже join не происходит.
are sort of represented at the golden storefronts. This takes, yeah, we do it on prod info.
Пока не используем.
We have testing quad on Trino. We haven't used it so far. In the future, we will use the CI cluster.
Денег не потратить, потому что можно нарисовать очень крутую инфраструктуру, архитектуру.
We don't want to overspend. You can draw a beautiful architecture, but it will be too expensive, and it won't work, or will work worse. But you are using Iceberg. Why would you need a sample? Why don't you make a different branch? If the costs for storage are higher, if you use
Старый Hive. Я не уверен, что там
the Iceberg. We have an old Hive. I'm not so sure that we can use snapshots. And probably it is also about the balance. So we are looking at how much we spend on the storage and how much on engineers. A small question. Before you said that you have a system analysts that they do coverage fronts and work with data. We call this profession the data platform, and the head of system analysis has a somewhat different outlook, and these are the people who can do SQL and don't move outside Kavan. And the system analytics is the DWS, and it takes people with certain skills. And these are the people of the future, data engineers. And so they are data engineers. The data engineers build the platform. There shouldn't be too many of them, so that through their suffering they would give birth to beautiful architecture. And you said that the maintenance of spreadsheets is important. How do you automate the process? The maintenance of spreadsheets is done in the following way. We have ducts that launch the delete of files. They clean up the personal schemes, and Java comes to your personal scheme, and it deletes everything. And people know that it is just for daily work. So we write ducts. All the spreadsheets, you have the ducts that clean all the spreadsheets. The Trino has this whole functionality, and all we have to do is to launch as SQL code for all the spreadsheets, and it works beautifully every day, and some maintenance is done on this. This is fast. It doesn't take a lot of time. You have to think about this and do it. Okay, choose a victim. Who are you going to give? Whereas this goal that asked about system analysis, because it is her pain. Give her.
Остались ли те, кто задавал вопросы на прошлом докладе в зале?
Are there any people who asked questions
Получается, Бронислав
before? Okay, so Bronislava is getting
Если что,
book.
обращайтесь. Ну, реально добавляйте
And
QR-код, поставьте, пожалуйста. Я
so please write
Не, просто мне потом
something.
Дима скажет, что
And
очень хороший доклад был и самый лучший, все признали.
otherwise Dima will tell me that I was simply the best.
О, мне рюкзак
So write your honest feedback. Okay, cool. Okay, now we have a break.
Смена ведущего. Теперь буду...
Now we are changing the host. Now I'm going to be the host, and I will introduce people now after the break. I hope everyone is ready to continue listening. Now we will listen to Yevgeny, who is going to talk about Apache Arrow.
Меня зовут Женя. Сегодня я вам
My name is Zhenya, and I'm going to talk about Apache Arrow. And
соответственно, это базовый кирпичик современного
this is the basic cornerstone for modern data
грузовики и другие
treatment. We create autonomous vehicles, autonomous trucks, and we use them to carry cargoes on Russian roads. And I am responsible for HD card. How is it different from the one that everyone has in their navigator? It is more detailed, everything to be able to move autonomously, and it is extremely precise. So it is no more than 10 centimeters. And it's similar to real-time systems. And probably in this conference, there would be people who would like to do the testing. And so where does data management come in? And autonomous driving has a lot of data, and certain actors use that to exchange messages. Some of them collect raw data, some work with algorithms, and all of those things are put together on the hard disk on a computer. And then all of this is processed. And what volumes are we talking about? It's up to 7 terabytes during one drive. And this is per car, and we have a lot of those. And once they come to the hub, immediately the data goes into stream, and how we can use them. Definitely, we have the business big data, and this is calculating the metrics and also understanding the bottlenecks where we can tune it better. And so this is the high level of technology where you're looking for splitting the hair, if you will. EML tasks, preparing data sets and data visualization, and definitely building the maps. And Russia is a huge country with long roads, and so building one road even creates a lot of data. And we have a lot of infrastructure. We have a cloud provider, and that's where in S3 we have around 5 petabytes of data, and we rotate this data, and we delete what's not needed. And we also have a computer. A stack is quite big. It's all open source technologies. We are not using anything proprietary. We started with Spark, then we moved to Arrow and Spark, and more specific libraries for our tasks. So we have the task of processing video. This is a video stream, and this is a sequence of frames for which we have to use a certain model. And the volumes are quite significant. If we are talking just about mapping, it's not about the other 200 cars. It is, we will have 3 billion, 2 billion images for the summer. And what do we have to do? We want to have a sequence of pictures to process them, either in sequence or independently from each other. And definitely we want to launch machine learning on them. And we remember that there are 2 billion. If we were a streaming service, then we would keep them in the following, store them in the following way. We would have chunks of video data. We would take them through the machine to compress, and we would put them on a playlist, and then we would have a video the way it is, the streaming video. This is optimal for storage, but suboptimal for usage, because every time to get a picture, you will have to decode it, which is a non-trivial task, because you would need certain function, and it takes a lot of time, and this is suboptimal. And so the issue is, when we keep the issue, we don't have metadata, and we need the link between geodata and other data. What are the other options? Every file, every image, we can decode them once and keep it on S3. And this is good, and this is easy to read. But it's not convenient to list it. If you have listed millions of files in S3, you know what it is. And now we have issues with handling in S3. And for example, we have a PNG file and we do the compression, but still it will not be as high as in a video stream. So it doesn't work. And it could be something between the chunks of the video stream and separate files. We could decode the video stream and keep it inside Parquet as separate images. Then in Parquet, we will have the heavy column with PNG, but we can read it separately. And to get access to each of those, we could also use it for Parquets. And apart from this, we also get metadata. Parquet is an expandable format. You can add a column and use it. We have around 10 columns together with this block column. So the result is worse than a video stream, but in terms of using it, we can ignore it. And I said that we could do a lot of things with the Parquet. And one chunk of data is around 20 seconds, and then you put it into Parquet and PNG at the optimal size of 256 megabytes. But on-demand access is not so trivial. First of all, we have to pack the data so that we could read minimum data when we read the rock group. For this, we need to reduce it to a smaller number of rows. Through trial and error, we came to the number of 5. And we also have to learn to read one row group and not to read the heavy column until we have filtrated everything we wanted. And we also don't want to download all the data in the files. So what we have for this, we have Apache Arrow, the one that I'm going to cover going forward. And very quickly, what are we doing? We created a data set with our Parquet, and we have a certain scanner on it, and we write certain parameters, then we read batches, and we take one element and we do non-trivial operations. For example, we could do something for OpenCV, and that's what we do for every row. And this is how it works. And we don't read the blobs, and we filter only according to light data. And now a little bit more about how it works and why and how we get these benefits. First and foremost, Arrow is a library, definitely a low level on the with the language of CC+, and it is a standardized model to store data in the operational memory as a colon, but not only, but it can also use 12 other languages of programming, and migration is possible between the languages, and you can write and read in all the languages. So interop is ensured. Apart from this, there is a strong compute engine and also mighty reading and recording, and the protocol of data exchange of flight SQL. Now a little bit about how data works. Basically, all the types are similar to what you used in Spark and Pandas, but the specifics are differentiating Arrow from everything else, and that's why it is so fast and optimal. The very basic brick there is Arrow memory buffer. This is the sequential part of the storage. It is typified, and the structure itself is as strongly packed as possible. And we keep here the Biden chain of all the rows. Now, how do the columns work? And we have the value buffer, and in case of a row column, there are all the rows. There is an offset buffer with all the offsets, and this is where our line is. And we also have the mask to identify which objects are null and which ones are non-null. And how is this different from what we had before? In Pandas or NumPy, the lines and complicated things are kept as objects, and we could have X20 overhead, and in Arrowhead we will have just X two overheads, that is doubling the operational memory. How do we handle this? We structured that into separate fields, and above them we have the structure of headlines where we keep the metadata, and in arrays we have the data itself. We have the structural column, and it has the bit mask, and it tells us if the whole element is null or non-null, like number 3. Then we break it into two, a row column and
маска, которая говорит null или не null, вот эта строка.
they in one, and they have their
Там
own
хранятся данные. Вот. И, соответственно, в винтовой колонке просто
masks,
данные в value.
which says if it is null or not, and an offset is always 4 or 8, depending on the enter, and it is quite a rich library of types. And if the data
То мы их делим на
cannot fit into sequential memory, then we have a chunked array, and you can iterate through this. And now let's move to
такая
2D.
структура, как record batch.
And there is also the record batch, which is a set of record arrays, and there is a scheme and arrays. Each array has the same number of rows, and it is backed into the row group of Parquet as is, and they are easily handed between different processes when we are talking about column handover. There is also a row table. A row table is the compound record batches and chunked arrays. And there is the compute engine, which is not very convenient, but you can live with it. If we don't read all the data in the memory, then we can set up the data set where we will have the filtration, the parceling, and we can turn it into the iterator of record batches, and or otherwise we can scan it. And scanning, like I said before,
которые указаны в сканере, то есть в
only reads the column that
фильтрует, получает
asked for in the scanner, and they get the numbers of rows, and then they read everything else that is needed. We can filter everything. This scheme ensures that we don't use operational memory when we read data. And like I have experimented with Parquet, it first reads the data and then starts filtering them if it cannot prune them. And pretty often it cannot prune the data. And that's not all of it. You can also handle the data with pluses. All of these primitives are available in all programming languages, but you can also implement that using just the pluses. And we did it at some point, and we write data in Parquet with Apache Arrow using pluses. Since we have the self-driving code on pluses, that's why we do it in pluses rather than in other languages. And that's what the data usually looks like for other companies, but that's what our data looks like. For example, it's there in the Market Labs, and we somehow have to do something. And we have something that is responsible for certain functions of self-driving, and we want to reuse it so that we can do it with C3. And how do we make sure that we marry pluses and Parquet? We write the package with pluses, and then we process the data. We don't want to write the exact pathways because it takes compilation. It's long and inconvenient, so we use the Python packaging, and then we transfer the data to pluses. Arrow has the mechanism of working which ensures that without copying and implementation, you can get data if you got it in pluses. And so the data itself is kept in pluses. And what we can do, we can get
ссылочку на таблицу, и в плюсах дальше
the link to the spreadsheet, and then in the pluses we can retrieve specific rows and columns, and that's where we handle the data. In essence, this is all we need to do complicated work with the columns and a specific row of a specific column. So we are taking the necessary grains from these parquets. So you can ask me if Arrow is so cool and if you can do things like that really fast with little storage capacity, why don't you throw everything away and jump to Arrow? Because it is hard to use. This is a low-level library with just primitives that I mentioned. There are some more. There is no SQL engine, all the other things that data engineers use daily to handle data. So this is why you cannot just
Pandas, Polars и все остальное.
throw away Spark or
Пошла индустрия.
Atlantis, Polars, etc. And where is the industry going? It is trying to embed Arrow as a compute and a RAM engine into all the other frameworks that others are using. That's what it looks like to long-term store the data in S3. You use the library with Iceberg, PUI Iceberg, and we have Arrow layer in memory. There are quite a lot SQL engines, and they use Arrow as a compute engine. And when there is a lot of data and we want to calculate them on different nodes, then we have the layer of distributed computing. Let's start with Pandas and Dasco, which is a distributed analog. Why I'm talking about this? Because DSs love Pandas, and they would take it at any given time. Pandas has a lot of issues, and the creator of Pandas highlighted that in a lot of articles, and he offered something to overcome those. He created Apache Arrow with a core team of several people, and not just did they come with an Arrow as a thing in its own right, but they also made sure that it embeds in Pandas as a compute engine. What do we get when we have embedded Arrow into Pandas? When we get good work with nulls, if you have dealt with that, when you have an identifier in Pandas, and then you have a null, and then your identifier becomes null, and it dissolves and fails, we also get higher speed, and we can reduce the memory usage by the factor of 5. There are certain things that have been implemented, and this is compute for Arrow. There are things that haven't been implemented yet, such as grouping the row and mixed types. And the issue is that all the things that were not done in Arrow went back to Pandas and slowed Pandas even more. Now this has been resolved. The distributed version of
здесь выигрывает.
Arrow Dusk is also benefiting from the implementation. Now let's move to production. Everyone is using Spark Executor, and we want to reuse the Spark IP because, so that the computer would use less operational memory and work faster. And this whole thing is called
Так вот, дело в том, что
Data Fusion. Data Fusion is also an Apache project, and this is an SQL engine based on Apache Arrow. It is based on Rust with the interface on Python and SQL. It was implemented in the way to make sure that it supports the maximum number of features for Spark, so there shouldn't be any migration issues. There are good icons there. And the creators of Data Fusion went a step further, and they made a plugin for Spark, which enables building the Data Fusion, embedding it into Spark as a compute engine, and we get a working solution, and then we use Data Fusion as a compute engine. The queries are still made by Data Catalyst. What it can, it moves to Data Fusion. What it cannot, it uses Java for it. And because of this, with the standard benchmark, it is twice faster than the standard Spark. But because you need the overhead for the distributed calculation compared to Data Fusion, it is somewhat slower, and not everything is yet implemented in Spark, Data Fusion, and Comet. And so sometimes you have to go back in Scala, and sometimes you use more operational memory. This is how Comet works, and the data is read with the native code in Data Fusion, and then everything that can be done in Data Fusion is done in Data Fusion. Then everything else that cannot be done there is done in Spark. Probably some of you have used that. There are also Pandas UDF, and this is an attempt to launch everything on Spark, but in a distributed mode. We take data from Spark, we read the data with Spark, and feed them into Pandas, and then we do whatever we like, ML, computer vision, whatever, and all of this, starting from 2019, has been used. Can this be sped up through Data Fusion? No, not yet, because there is a call, and then to get the data back in UDF, there is the row column, and you want to work with column data rather than shifting the data around. What is available for this? There is Ballista engine, and we have Arrow, and we launch it with Ballista. Ballista is the framework of distributed data processing, and it is above Data Fusion, and it's implemented on Rust, no Java, no overhead, and the scheme is similar to Spark. There is a driver and an executor, and the handling happens in Data Fusion, and the communication between them happens with data flight, and the features there are obviously missing, and there is no UDF, which is much needed. There is also the framework called Polars. It is based on Rust plus Python, and it works on one machine. It's not distributed, but it is faster than everything else. It can convert into other frameworks of data, but that's not so important. And as different from Pandas and Spark, it combines the modes. We can calculate straight away, or we can come up with a plan, optimize it, and do it as fast as possible. Because of this, it is better. And it is fully in production. We are using it for some jobs instead of Spark. And the syntax is similar. There are certain nuances there, but it's not complicated to rewrite it. So what we get is an opportunity to work on one node, what we use several nodes for before. There is SQL, and there is the SQL, and you can use it. And there are nuances there, and they are still working it the wrong way. And why? Because they use a really strange concept of window functions, and it is similar to Pandas, closer to Pandas. It asks you to sort everything out and to go through this. It's like done in shifts.
So the SQL interface doesn't work correctly. It doesn't give you an error message, a runtime error message. No, you just get the wrong result. So if you bring it over to Polars, please pay attention to it. At the same time, the Polars primitives work really well. It's just that SQL is not been streamlined there. So why am I talking about that? Telling you about that. So currently, this is the fastest data processing framework on the market, and it saves you time, computing power, so you can bring some easy processes from Sparks to Polars, and it will save you some terabytes. Yeah. There is also a distributed version of the same product, but it's only in OVS. Right now, we can't use it currently. We don't want it. I mean, there is open source. Why should we use paid products? So there is another thing. It appeared in 2022, which is even better than Polars. It's framework of data processing on Rust and Python, and it's also distributed, unlike Polars, distributed by default. It has window functions, it has Python, and all necessary integrations. This product is being developed very rapidly right now, so let's talk about it a little more. What else does it have? You can work with ML in it. So basically, you can run ML codes on Daft's primitives, and you can view the pictures which it gives you, because initially, the framework was built to solve ML tasks. As I said, there is a distributed version that is running on Ray platform. Ray is a computing distributed platform, that is to say, sending the tasks for computing and then getting the results. So Ray allows you to granularly adjust execution for each task. It will tell you how much resources, how much power it needs, disk space and all that. So Ray allows you to bring up subnodes and to scale the load dynamically. So what do we get as a result of that? We get the opportunity to take each UDF and set and see the resources needed by each batch. We don't see this in Spark. In Spark, we create the sessions once, and then we try to bring as many UDF as we can, so that as many as memory can hold. All this is done automatically. You don't have to recreate anything. You don't have to wait 20 seconds for Java. All of this is done as it goes during computing process. If something has dropped, you just change the resource and that's it. For instance, you change operation memory capacity twice, and then you set this function into all of the subsequent commands. All right, so let's draw some conclusions about Daft. So basically, we have everything that we need, and it's also quick and easy to use. So this, I think, is already a full-fledged substitution of Spark. And maybe in the next conference, I will tell you about that more. Unfortunately, it's not without nuances. It's all done on Rust. Rust developers love to create new libraries, to rewrite everything from plus. So this is what they did. They rewrote everything, arrow on plus, and then they added some smoothing. So right now there is kind of this back migration to Apache of Arrow. So both Daft and Polars are based on this library, so they will have to migrate once upon a time. Hopefully this story will have a positive conclusion. All of this is for data processing, but to store data, we also need to store data, right? And we want to store them in Apache Iceberg in order to be able to do what Dmitry told you 1 hour ago. So that is to say, Iceberg is being implemented, including implementation in Russia. Iceberg is good for data storage and for retrieving the data, and Python is good for working with Iceberg. It's good for working with Iceberg tables. So what can we get as a result? We can get metadata, we can read the data, we can read it by the framework which we like, because we added all the integrations with all the frameworks I've spoken before. We can also write the data in Iceberg right there. So this is done on Arrow, strictly on Arrow. So let's draw some conclusions. So Arrow right now is used in all data processing frameworks that the industry uses right now. Which are up to date, unlike Highway, for instance. And what does it give you? It gives us the productivity boost and also sharp reduction of operating memory consumption. And once you bring that down, you can add computing power by increasing the number of cores that are computing your data. Arrow is being implemented, as I said. Every time when you download a framework, you also download Arrow. All of this goes towards unification. I think that, generally speaking, frameworks are going towards unification. Yeah, there is difference of layout and all that, but if you basically change all of your drives into Arrow, you'll get the same thing. Of course, we'd like to have a nicer looking shell, but that's in the process. Unfortunately, Rust and the whole structure of Arrow development and the development of Arrow-based libraries is not without its problems, but the previous iteration that we saw, when we had Java-based frameworks and libraries, all of them were Apache, and they basically all disappeared. We only have Sparks which survived. So 10 years ago, we had about 30 libraries. So maybe here we even have fewer.
Yeah, but maybe somebody will write a new library. What do we want? We want to have a ready-made framework. Okay, let it be on Rust, but it has to be supported. It has to support everything that right now Spark is supporting. And of course, we would like it to work faster and use less operating memory. Arrow is developing very actively by itself, and everything that is based on Arrow is developing too. I'm talking here about Data Fusion and Daft. And while I was preparing this presentation, the Daft introduced window functions, pop-up window functions. So every time you download Pandas 2.0, you download Arrow as well. So let's dream a little bit right now. I hope that next year, maybe 2 years from now, there will be a framework which will support absolutely everything and will have a pleasant and fast working process. This is all I had. Thank you very much for your attention. I'm ready to entertain your questions.
У нас микрофоны справа и слева.
Okay, now please use microphones for your questions. Microphones are on the left and on the right.
Здравствуйте, спасибо за доклад. Да, у меня такой вопрос, а почему вы используете Parquet?
My question is this.
Ведь в ОРЦ у него вроде и сжатие.
Why do you use Parquet rather than ORC? Compression and index in ORC is much better, isn't it? So that's my question. Why Parquet rather than ORC? ORC has less integration with it. All the frameworks that I've mentioned, not all of them will work with ORC. Whereas with, yes, I mean, we can write everything in pluses, and Orc has all standard libraries written on pluses, but then we won't get to the features that we have in Parquet. What do we need from Parquet sometimes, and why are we still using Parquet?
На самом деле, Data Lake тоже я начинал строить, вот, это сейчас начал заниматься.
That was a while ago. But anyway, what kind of specificity we have? We run the plus classes into the structure of Parquet, whereas developers, the plus real-time developers, like to add new strings, new things, and it's very hard to do in the work. In Worker, at least and in Parquet, it allows you to add or delete columns to change their So Parquet has better support. Work is compressing better, ORC is compressing better, but maybe it has a better structure. But if we talk about evolution scheme, it's kind of heavy. So if we don't take media data, which is video, which doesn't change scheme-wise, but everything else, for instance, the algorithm outcome, it changes a lot. And you have to unpackage the scheme, you have to delete something, you have to add something. And we have these functions automated, right? So we have about 200 tables, and we don't want to support them manually. Everything is done automatically. We wouldn't be able to do that on ORC.
Вопросы?
More questions?
Слишком сложно, да?
Too difficult, isn't it?
Дим, ты задашь, да?
Dimitri, you're going to ask a question, I guess.
Я не знаю, на самом деле. Ну вот, короче, вот этот есть Arrow у нас.
Okay, so we have Arrow,
Chunked array. И как мы
and it has chunked arrays. And in operational systems,
то есть, ну,
memory blocks are logically they're together, but physically they are elsewhere. So Arrow in real time in operational systems, will it work faster or not, given this? Well, I haven't computed that, but I think so. Yeah, it might.
лежит в одном
because the block is all located in one space, in one spot. Okay, then another question. If we don't talk about analytics, but if we talk about real-time systems, is Arrow used in real-time systems? Well, we write all data that goes into Parquet in Arrow. So all data that comes in real time is collected into a buffer, then the buffer is going to Parquet. No, that's not what I mean. Let's say there is a car that is driving, the sensors are taking some pictures, sending it. So in real time, we have to do some analytics. How many kilometers have been traveled? In other words, we have to do some analytics that is not based on the inside system. Can you use Arrow for that? Yes, but we don't give any computing power for that, because computing power right now is limited. So to drive in, this driving needs all the resources that you have, right? So developers will take all of them. And then there is nothing left for analytics. So analytics is done in Click. When the car is just sending you telemetry, right? So the first versions of analytics were built on Click. Yeah, you can do it. The question is, why? Bulk of work in real time basically is implemented in row constructions, not in column constructions, column structures, rather. And other than that, yeah. I also have a question. You mentioned data fusion. You mentioned the strings and the way they are organized in memory, in Arrow's memory layout. Now, in data fusion, one Chinese expert, he put what is called the German string, this optimization and storage of strings in order to not look for them again when you operate with them. Do you think Arrow will incorporate this this feature, or will it remain strictly in Fusion? Arrow also has string view, yeah, but it's implemented differently. It's as if all the strings have been glued, and then if we talk on offsets, you have to do something else. When we speak about the German string, there is a prefix that is stored separately that allows you to look for the strings quicker. If you want to inline a string, you can do it. If not, it's dropped into the table. So it's a fancier system. Are you familiar with it? No, unfortunately, I'm not. But maybe, yeah, maybe they'll incorporate it. So the task is to allocate less power, computing power, when you work with strings. And in Spark, MR, well, not a issue, there's definitely an issue. Does Arrow have an issue with it? If we're talking about pluses, you can get a buffer and use this buffer as a memory block. You don't have to allocate anything. Yeah, but later on you'll have to read it, retrieve it, do something with it. You won't be able to do it without allocation, will you? No, I mean, you will be able to read it, but you won't be able to do an operation. But anyway, okay, let's forget about it. It's an interesting subject, though. There is a blog that used to be Chinese, now they brought it into Data Fusion. I'll give you a link, it's very interesting. Any questions? Any more questions? Well, it looks like it. So the best question, according to you? I like the questions about O or C. Yeah, true. These formats look alike, and the choice is not always apparent. Okay, please come up to the stage for the present, for the award, for the prize. Thank you very much for your question. Okay, well, that's it, I think. If this is indeed so, then we'll we'll invite the next speaker on stage. Thank you. Thank you, Eugene.
Ну что, можно продолжать? Сейчас у нас будет еще доклад про то, как
All
сделать
right,
магию быстро.
now we are going
So we'll have another
to
report right now about how to do
another
magic
presentation about how to work the magic fast, cool, and good. We will have two presenters, two Dmitris, two Dimas from the
Так. А это
technology
освещение вообще не нашей презентации.
stack. Oh, it looks like it is the wrong presentation. This is not our presentation, because this is not a presentation. It's somebody else's.
Спасибо коллегам, которые пришли. Зал пополнен.
Thanks to the colleagues who are here, we see a lot more people
Увидимся
here.
завтра на Дейлике.
And see you tomorrow at Daily. Oh,
Да,
this
мы
one is
вдвоем.
ours.
Я Дим Зуев.
Yeah, we are
и со мной Дима
going
Ольхов.
to
Вот,
talk
о,
in
даже
duet.
сплющил
I'm
обратно.
Dmitry Zuev,
Я
and this is Dmitry
инженер-менеджер,
Mankhov,
отвечающий за
and
инженерную
I'm
компанию
an
Quality
engineering
Technologies. И
manager
Дима, наш
who
ведущий, там,
is
старший
responsible
разработчик. Вот, Дима,
for
собственно,
the
расскажет про то, что он с
EM
командой
and data
непосредственно
engineering,
имплементировал, а у меня
and
в докладе будет
Dmitry
немножечко
is our senior
вводного.
data platform
Вот, у нас
engineer.
доклад
He will
50
talk
на 50.
about what
Сначала
he
мой
has and his team
контекст,
has
потом Дима в
implemented.
рамках него
It will be a
расскажет суть, да?
50-50
Ну что, давайте начинать
presentation.
тогда.
I will talk about
Вообще,
generic things, and Dmitry
на
will
основе
present
чего
his
этот
case.
доклад хочется
So, what I would like to use for this presentation, a year ago, at the Positive Hack Data, the first person to speak was Vladimir Ozerov, who spoke about the state of big data of the past 30, 40 years and how it all developed. And one of his items was that there was the data system management manifesto, and he spoke about what could be a good approach and what interesting solutions could be used to put together the bricks. What I really like is that in LGP, this article is asked Pedro Petreira, and there is also Wes McKinney here, who wrote Arrow, and before that did Pandas. So there are a lot of really significant authors in this paper. How does the Composable Data Management System Manifesto fit in? I believe the main idea of this paper is that we can reduce redundancy via this approach, because we have some prefabricated solutions which match each other quite nicely, and we can use them to build something. One of those is Arrow, as Zhenya said before me, and it can be embedded in a lot of things. This is a default memory layout for big data frameworks, and by doing this, we utilize versatile solutions that can be reused across different systems, and easy start and focus on innovation, which ensures scalability, and then we can use off-the-shelf modular components, and we can focus on what is missing there. Before, you had to go bottom up to build the whole stack. Now you can just tackle the issues that are not there, and sometimes you can take another component, and these are the two main ideas. And the authors look at a lot more, but for brevity, that's how I present them here. What is the issue at hand? The classical stack for big data looks like this. This is a YDB, and the guys are going to talk after me, and they have modularity, and there is the protocol of LDC, and there is a separate query memory processor and distribution transaction management and tablet and all of those things are showed here. But these things are not so easily replaced and substituted, but without hard fork, you cannot replace the components here. Really important components like query optimizer or protocol and the byte grinder, putting it together would be kind of hard. But if you want to do that, you could. Now, what do the authors suggest? They suggest a modular data stack. On this slide, and this picture comes from their paper. It shows that everything can be split into the language layer, the optimizer layer, and the execution layer, which is common sense and not rocket science. And please pay attention to the language. It's not just SQL. And you've got to remember that. It turns out that you can use other tools to handle data, not just SQL data. This is the level of SQL. And whatever you write in SQL or some API, somehow you have to put it into the optimizer so that it comes up with an optimized plan. And here you have the gray square, which shows IR, intermediate representation in between. This is an intermediate representation and substrate. Substrate is the only well-known representative for the IR. There are actually several, and there was a big discussion about that, what are the good and the bad features, and whether SQL is alive or dead. So intermediate representation is the substrate, which is about the logical plan. So we get the optimized plan, and then in the query optimizer, we will feed it to whoever does the execution. And there are different situations. There is something distributed and there is something less distributed. And here you have the library and the vlogs. So this is what will work. vlogs, the fusion, this will work. And the Spark, for those of you who know it. And the authors believe that you can make up the working solution using these components. I wonder if anyone was able to put it together, but anyways, we tried. Now, this is the first flight. This is Aeroflight and DuckDB. What is Aeroflight? It is a versatile transportation protocol. This is part of Aero, and this is about optimizing how can you use minimal locations and how you can put together your components, different components such as Walker's shuffle can be built with the flight. And this is an arrow. It can run through the network, and it is cheap in terms of the location. And this is a connector between the analytical engines and the client apps. A few words about Parquet. Zhenya covered it a little bit, but what's good about Parquet? It has a lot of layers, and definitely what's important, the data is stored in columns, and they use column groups, and inside these columns you have the pages, and this also has incredible photos, statistics for each page group. Row group, rather. And through the statistics, you can do a lot of cool things done by the engines, and you can run this group, read it or drop it. Now, Parquet versus Arrow, despite the fact they are very similar in their representation. In green, you see the Parquet page and the definition levels and non-null values. You have definition levels and non-null values. In Arrow, you will have the values vector and the null vector. It is easier to move between the two, to migrate between the two. What is DuckDB? This is something that can be embedded. SQLite is used in iPhones, and SQLite was used by smart guys for analytical data and a lab, and they were tackling the issue that the distributed engines up to a certain level don't need. You can process a lot of things on a single node, but there wasn't a convenient one, and DuckDB was in release. 2 years ago, it wasn't in release. It works as a library. It's a processing story. So you have a program in the language that you like, and you raise your in-process to the database. And this has zero dependency, which goes counter the module principle. And it doesn't have the dependency of everything in one repository. And DuckDB unites more things than we would like to see, but this is done because DuckDB has the language, the optimizer, and execution engine, and this is it. That the intermediate representation evidently is there, but it's their own. Why so? Because they focus not on versatility, but rather specialization. What are optimizations you want to pay attention to, and why we selected DuckDB for our solution? This is good joint rewatering, and we have a DDCP built on the dynamic programming. This is really cool. Read about that. And the expected features and partitions. And in March, they also entered the blue filters, and everything will work. It's not an optimizer, but an important thing for DuckDB is that the memory will uses buffers, and without an allocation, you can move them to Arrow. And Dmitry, now you can talk about our case. Okay, now let's talk about the implementation of Arrowflight and DuckDB, and we'll start with explaining why we wanted to do all of this. And we have a data lake on S3, and we have differently formatted data there, and the data is in an iceberg format primarily, and definitely they have Parquets under the hood, and we also have an RS catalog for metadata that it keeps, and we have data sets there. And our goal is to make sure that on demand they can be downloaded in a laptop. You could do that. And we also have certain limitations. The security part is not to be ignored. And we also think about savings. If there are no queries, why would we keep everything going and have the workers there? And we also need the versatile API to integrate with various analytical systems. And the first thing that comes to your mind is, why don't you use Trino Iceberg? It can read it, it can work with Parquet, it supports Iceberg REST catalog, but the downside is that it is too heavy for us, and there will be a lot of data between the workers and planning, and we just need to download the data set. And also, when we use Trino, we will have JSON, and it will be converted, and it doesn't look really good. And DuckDB is the second candidate, and Dima has already enlisted a number of upsides. It is easily embedded in any code in different languages, C, Python, Java, and Rust even, and it supports Iceberg and Parquet, and there is an integration with an RS catalog, but this is also a downside because it is new, it is a preview, and they are implementing it their own way, and you can save resources with it because you don't have a lot of workers, you can control it, and I will explain how. And it looks like DuckDB is good, but we have to improve it because the downsides we have there are that the security is not very transparent. You need a token for S3, for RS catalog, and it's not really clear how to simplify that and streamline that. This is a versatile IP, and we are not just providing DuckDB. Just so, we need a contract. And DuckDB, if you add an arrow flag to it, it looks like all of those downsides are mitigated. We will have an API so that we add more security and also the isolation, and also the integration with the RS catalog. And now let's talk a little bit about Aeroflight. And I'm not going to cover Aero at length because Zhenya has covered that already. If this wasn't enough, you can also have a look at the presentation, catching up with speed from G-Point. And so it is Aero plus GCPT, because this is Aero. It has 0 copies for the level of gRPC. This is a well-described standard. And basically in any language, in any popular language, because this is gRPC, you can do the implementation of this API. And we have all the advantages from Aero here. And what can Flight do? It can do several things. It can get data and the do get, the do put, doing the exchange in one operation that is two streams and also additional operations that are needed. To begin with, to initiate the protocol, to get the schema, the list actions, the do action, etc. Additionally, and this is done for Aeroflight SQL. Now let's have a look at the do get. This is one of the implementations. What is happening here? The client sends a descriptor, and this is a command or a pass to the data. This is a key to the metadata server. We know where everything is and where the data server is, and what it is sending back is a certain ticket that you have to send, and also the address of where the data is, and there is the communication between the data servers, because this ticket should show that this is the data to be identified, and we get to the invoice, we go to the data server, and we get batches, and this thing can also be decoupled, not in parallel, and the data can be broken in further chunks, and several data servers can operate, and we can to get and put in parallel. And the metadata server knows something but cannot respond because it's not ready, or additional computations are needed, and several data servers are needed. And then it's not about get info. We are sending several queries, and if we get an empty endpoint, we have to request once again. And when there is a specific address, then everything is good. We have spoken a lot about DuckDB. It's easily embeddable. It works well with Parquet because there is zero dependency, and we can take it on without additional libraries and use it. There is no incompatibility. The only issue is that it is implemented differently on different catalogs, and it can work with Parquet, Iceberg, and other catalogs. This is written with C, and this could be a downside if we are using Java. And now let's have a look at how we put all of this together. And this is a flow diagram, and we have the same we have a metadata server and a data server, and we have a client here. And the client is sending this, it sends the CR, and then they create the instance of the data server, and it is ready to process data, and and we get the metadata server message that here is a ticket, and the client knows here is the address. They send the ticket, and they get the stream of specific data. If we put all of this together, on a component diagram, you will see exactly the same. So here is the block chart of this. The only data I added here is the metadata server talks to the catalog. I want a certain data set in certain space, and probably you could see that there is no security. I removed it for simplicity reasons. But the security part happens here too. We have an identity provider. The token is checked, then it is checked with the protocol, and then the data server with S3 and DB, it sends the queries to the S3. Now more about saving, and the data server knows when they get a query, and they report that no one came here for a long time, so it is time for me to rest, and it sends this information to metadata server, which will remove the data from the server. So what issues have we encountered as we were doing this? The implementation was done with Java because Java and garbage collecting and Arrow doesn't have that. It has buffers. Then so it the Arrow and Java don't match well, and we are using the buffers, and we have to handle the memory in a specific way. This is why we have the allocate buffer, and we should have the root allocator. There is a whole hierarchy of those allocators, and you should create a certain size allocator hierarchy. And for example, this is the code taken from DuckDB documentation, and here they show how they create it, and they're doing it for demo purposes. But there is no allocator there, root allocator. If you don't have root allocator, then they will use max value, and it means you will be out of memory unless you control it really tightly. So you always have to control this, and also to clearly indicate how much memory it needs. And DuckDB is in memory, and it's not in Java. And here we have the same thing. We launched DuckDB, we created a connection, but outside JVM, it does something to the memory, and you somehow have to control that, to monitor that. And you have to calculate how much is needed to set the cap, and also remember the parameters, like the streaming of results. If you don't use it, then with big data, there will be out of memory because everything will be downloaded in the memory straight away. And there is a comment from developer of DuckDB. At the moment, this is expected behavior. Not everything in DuckDB respects the memory limit yet. In the future, this will change. So not everything is compliant with the memory limit yet. Sometimes they can cross this memory limit. You have to bear this in mind and add additional memory as a buffer for this. And we try to do that through trial and error with our queries. And we identified that this is the distribution that is good for us. And it doesn't create any out of memory or anything. And we have to work with max direct memory 10, and you don't need more. And the rest is for a heap and other regions that JVM has. The next issue we faced is the issue of too fast server. What if we have a slow client and they cannot handle the whole set of data? We had a stream, and very fast the stream just stops. What happens then? The server will be stopped, and it will keep the memory in the buffer. And then, if you don't monitor that, we have several. We used all the memory.
So therefore, one needs to have back pressure strategies, right? So this is an example of an entity that is embedded in Aeroflight. You can create an entity, you can register it there. So this is a standard start listener with the buffer, right? So we embed it there, and we wait for the client to be ready for timeout of sorts. And if the client is ready, then we send it, and then we finish it. But not all of it is as simple as it sounds.
Надо делать через создание отдельного потока.
In reality, you have to do it by creating a different execution flow. And if you do that, then you'll have no problems. So we added this execution submit function and then kept everything the same. And we check the client readiness before we upload it, in order not to keep any extra things in the memory.
Zero copy.
This is the way it works. Other nuances, zero copy. If you go to Aeroflight site, they'll tell you that they have got zero copy, all is good. Well, there is actually a tumbler for zero copy in practice, because by default it doesn't work. And this tumbler exists in two spots. In gRPC listener, and you have to or through a flag. Or that will take care of it globally speaking, or if you need it locally through a method. And then, again, there is a nuance that we don't see in the documentation, but we only can see it in the code, and you have to dig in for it. Namely, if we start using true zero copy, then the bufferized entity in the root where arrows are stored has to be allocated new, right? Otherwise, it will rewrite into the same address. And the practice shows us that the allocations decreased by 2 after we switched this function on.
Вот этот как раз момент. То есть
this is this moment
сделали true, да?
code-wise. So when we turned it on, that is to say, gave the true value to it, we have to put an extra line, allocate new, after put next. Then it will be a safe zero copy. Okay, so let's draw some conclusions. What did we have in the end? Together with the Kubernetes operator, we managed to create an economical approach when everything is created as soon as query appears. So we have a data server which starts using RAM, and when the query has gone, it stops using the RAM. If we start implementing Aeroflot and DuckDB on Java, then we get all the problems of kind of lost in translation things, because they're different languages, different paradigms, and both language works with the memory differently, and we have to control this. So we have to calculate the max direct memory. We have to control the container. If it's at Kubernetes, we don't have this opportunity not to put a limit. Limit has to be placed there. In order not to be out of memory, we have to monitor memory very keenly. We cannot forget that the client can be slow, and his slowness should not impact our realization implementation. And the zero copy, again, it sort of is present, but not quite. So we have to control that too. All right, so this is what I had to say.
Ну что, теперь можно задать вопросы.
All right, now is the time for questions. Do you have any? Well, if you don't have any questions, I will ask one.
Подстава. Да нет.
Okay, it's a setup. It's not.
Про, собственно,
All right, Dmitry was telling us about the slow client
про zero copy.
and about zero copy.
До этого дошли, и как там вообще была эта история.
Can you tell us how you got there, right? What steps did you take when you realized the zero copy doesn't function? Oh, zero copy. Okay. Well, I found the zero copy issue during the process. You look at the AP, and it tells you set zero copy, and by default, its value is false. And we thought that it's because of the slow client. Yeah, in practice, it is because of the slow client. It's just that the flow was blocked up until the client, while the client part was being computed. It all happened during the development phase, when the connection between the machine, kind of the mainframe, and the local part lagged speed, and when the reading on the client side was much slower. No more questions from the audience? Then maybe I will ask a question. We're not going to give you the second prize. Oh, I don't need any prizes. I noticed one interesting thing, that there are some specific things that you have to do after the zero copy that were not mentioned in the documentation. Could you tell us whether you discovered this before the fuck-ups or later? Before. Well, I don't think I was entirely sincere there. There is in Java document mentioned, but it's kind of very implicitly described there, right? Just don't forget the allocate new. Oh, allocate new, it makes sense, right? But it's very strange for Java that you can write on top of it. Yeah, well, thank you for those who put it into Java talk. Oh, Eugene wants to ask something. Yeah, I have a question. Why is it not on Rust? Why is it on Java? Kotlin is even worse. Okay, all right. We've got Kotlin stack historically. the way it's been.
Я не знаю, не КХДБ, например.
Yeah, why is it
Потому что Олег сказал.
DuckDB and not KHDB? I think Oleg already mentioned that.
Ну что?
Тогда пауза до следующего доклада.
Okay, small pause before the next speaker comes up. Please do not go far. Let's all stay put.
кажется, пора продолжать. Сейчас у нас еще один интересный доклад от
Okay, I think we have to go on. We have another interesting colleague.
которая сможет выполнять сам.
We're going to talk about the
And now we are
database that will
going
be
to
able to
continue,
perform all
and
different
we are going to
things.
look at the base that is going to do everything and properly. Hi, everyone. Thanks a lot for being with us in such good weather. I'm Oleg Bondar, and we work together with Alexei Dmitriev in Yandex, and we develop our database in Yandex DB, and the amount of data is growing fast, and there are a lot of difficulties around that, and we want to make sure that the database would have everything, and we have to build the security platforms, and we will show how these tasks influence our development, and then when we tackle these issues, how much easier building such systems becomes. And we will talk about both parts. I will talk about our platform, and Alexei will talk about how we built our platform on YDB. Let's start with the very beginning. So what is YDB? It is a database that we did in Yandex, which is scalable and really productive and really robust. And one of our main tasks is to survive different catastrophes and to work with a lot of data. It should be fault-tolerant and versatile. When we started the development, we wanted to build the transactional and traditional database because by then there was this famous scientific article, and the trend started about the evolutionary database, and then the new term was introduced for a hybrid transactional analytical databases. It all started with the database that should work in one memory, and then Gartner said it could be one database, and you can keep the data for transactions and for analytics, but anyways, it will transfer the data internally, and closer to 2020, this class of the databases became more distributed. At first, they were columnar type, and then they became more distributed because no server can keep all of the data, because it can be hundreds of petabytes. We started the development, and we understood that we cannot do just that transaction, and
когда мы стали популярны уже как транзакционная СУБД,
And when we became popular as the transactional system for data management, on the one hand, every project we had, they wanted to create the base for the tactical tasks, and every team also wanted to have another database for logs, and the number of logs increased, and the tracing became
одно из направлений
the thing. And one of the areas that we worked on, apart from the relational
хранения логов. Достаточно
system for database management, we also had to tackle the databases for the logs, and this is quite problematic because the log usually is sorted time-wise, and all the data
какой-то последний набор ключей. То есть масштабировать такую систему
goes into the last set of keys. And when there are too many logs doing the search in the transactional database, which is
достаточно неприятно. И нам пришлось
used for both purposes, becomes difficult, and we had to come up with a full analytical engine because
задачи из области
a lot of
безопасности, да, вот в частности,
the security platforms, they are complementary to all of those issues, and we had to address all of those. When we talk about hybrid databases, there are four key difficulties, four key challenges that you have to tackle. And number one is how this data should be kept. Why can't we use just one system? Most likely, the
мы говорим про информационную базу, это там могут быть миллионы запросов в секунду, но затрагивающие небольшой объем данных.
workload can really vary. In analytics, there is
Или сотни таблиц.
a small number of queries, but it can need a lot of other data. And we have to think about how we should store that optimally. It means both columnar and row storage.
Аналитику по данным, которые
And we want to get access fast to the data that we have there in analytical storage of this database. So we have to transfer the data from the columnar database
хочется сделать это
and from the row base to the columnar base, and we want to do that inside the system without anything external. After we transfer this data, we address the issues of data freshness. We have to ensure the queries for each of those subsystems, and we somehow have to learn to isolate the resources. And today I want to cover in brief what functional features we had to add to tackle the issues. First, I will cover what the system looks like. It is broken down into layers, and one of the key features is decoupling. So the layer of computing is separated from the layer of storage. This can be done logically on ordinary servers. Some processes only do computing, and all the data is stored in the storage layer, which ensures that any layer can be scaled up so easily. The database can keep a lot of data, but the number of queries is small. Or the other way around, 1 million queries per second can be sent to a small database. And then you have to split it into different layers. The query processor working with the user ones, and then the layer called tablets. They are small logical programs, and that's what you can call them, which actually work with the data in different formats. And it could be the program that works with the data of the topic, and under the hood, there is the data, and each program has its own data, and it talks to the layer of distributed storage, and through put, get, patch, delete, it works properly, and the storage layer ensures that all the redundant copies are kept in storage. And what we had to do additionally, initially we built the system on tables, which is a primitive thing to do for any database. We have the tables, and a table has a mandatory primary key, and the primary key is also the
сохраненных данных, загруженных в таблицу.
Key for the system. So the system collects the data for the collected data and the queries, and when the workload increases, the system itself makes a decision that the spreadsheet should be broken into chunks. And the hardest thing is not sharding. You can do it once and easily, but when the nature of turning to data is changing, then we have to do a new split up. This is done automatically based on statistics. When we understand we have less data or less workload, what we do, we merge the adjacent shards so that we rebalance and adapt to the inbound workload. For analytical workload, this wasn't enough. We had to add a different way of sharding based on a hash, on a key, because here in a massively parallel system, we want to be able to use all the computing resources. So we split all the sharding throughout the hash, and we spread this throughout the cluster. So when the query comes to the system, it is sold to all the areas, to all the nodes, and we can then work in parallel. So if we have to increase the amount of handled data, automatically the shards are distributed throughout the cluster, and the productivity increases. Since we had quite a lot of time to work with logs, when we were a single system for log storage, we wanted to somehow cap the growth of the size of the spreadsheets, because anyways, even when there is a timestamp, we have the overheated shards. What we did was we split the data by projects, and since there is something similar to a filing system, we created we broke this into projects, further than into stages, hosts, and pods. You can build a certain hierarchy, and then the data is kept in this hierarchy. But the volumes of projects became so huge that this wasn't enough. But anyways, we believe we have quite a practical approach. There can be 1 million different tables, and creating every time a table and keep a metadata when there is 1 million times more volume. This is not enough. And we also want to redefine the qualities of downloading the data and uploading. So we understood that we had to do a column store, which is the scheme that has the tables that are one logical chunk. And for similar logs, now we create this through logs and to change all the tables, you change the log store, not millions of tables. And there can be a lot of data in the tables, and the system is distributed, and the shards are on different hosts. And to do the final calculation on the node, we could flood the whole thing. We push down all the calculations as much as we can. They can be built as simple arithmetic operations or some preset the functions, everything towards not just minimizing the reading of these disks, but also transferring data. And the next issue is about the data freshness and data transfer. And we had a solution for replacing Kafka, which we are already using in Yandex. And in the same database, we can create topics and use them as the replacement, a substitute for Kafka. And this is FIFO sequence, which can be split just as the table by parts. And to transform the data from one shape to another, we want to avoid external tools. We understood that we could take the topics and use them for the transfer, but not to write any additional apps. We implemented this through a transfer, which enables us to configure the tables and transfer data between different things. It could be transferring data between the columnar and row tables and do some operations on them. And since we want to continue working in the system with the consistent data, we also added the transaction support. And this is why we wanted to have the support of transactions between the topics and tables. You can read data from the topic, and then you can write it in the table, and then retrieve it through one line of code. And we also had to work on the optimizer. And in the basic system, we had quite a simple optimizer, which was enough for us. It was built on the basic set of heuristics that we have accumulated over the years of usage, and to make sure that changes in the code doesn't result in destructive regressions. We have the collection of queries, explain planes, and statistics, and we run this through the so-called query checker, and we run this sample of queries on these new rules to make sure that we do not fail. But this is not enough for analytics. So over the past few years, we had to develop the cost optimizers that is based on the statistics and information that we get from the tables, the size of the tables, the number of rows, and when we keep data column-wise, we do not have enough. We have to collect the sketches of data about how much volume do the data take. And here we use modern algorithms. The algorithms based on GitHub and we look at all the possible options to identify on a lot of joins in the query. It can be up to 100 joins, and how we can optimally transfer the data throughout the network. With all of this experience of building the systems and storing data, we built a versatile solution, and now we want to show to you how this works and what we have done with this. Hi, everyone. My name is Alexey Dmitriev. In YDB, I am responsible for the stream data processing. What is CM? Is security information event management system. It gets a lot of data from different sources, and then among all the data, it tries to understand if everything is going fine. If a person is trying to log in their laptop, but the laptop is closed and the person left their workplace, something is probably wrong. So this is how the system works. To make sure that the operators get the information that we have an incident in the system and the response is needed. So 3 years ago, we were approached by people from Yandex Cloud. They want to develop their own system of Yandex Cloud, and at the start, it should handle 600,000 events per sec, and it should increase exponentially because the cloud is growing. All the data that is transferred should be stored for 3 years because there is compliance and regulators' requirements and common sense. Everything that happened, we have to keep. And in 3 years, as you understand, there is a lot of data. Not only should you keep this data, but the security experts should be able to work with this and look for something. But the most complicated thing is not that you have to store this data, but the people in the cloud are really concerned about security, and they believe the time for identifying the incident should be in seconds. The traditional systems that work with security, usually they get their volume of information, somehow accumulate that inside the system, and then every 10-15 minutes they try to understand if there were any issues there. And so the response time is at least 10 to 15 minutes, which made them unhappy. And you can only handle that with a stream processing. You process the data in the real-time mode, and you make an immediate decision if everything is fine. So there are no delays, and this streaming approach is good. Apache Flink, Spark, Apache Beam, there are a lot of those which can process data as a stream, and to make the systems easier to use, they offer the syntaxes to make it easier, and this is similar to the traditional query. There is a filter, and the only difference is that in green you see the special stream commands that can result in certain results, but everyone who has written anything in SQL is used to that. And at the end of the day, how they wanted to see the CM of Yandex Cloud. At first, there are sources of data, then there is the node of normalization. Normalization is an answer between what is similar between the laptop and, for example, the door sensor. They both have an IP, so they all have IP addresses, and normalization is that you are taking the input data, inbound data, and if in the data there is an IP address, if there is data about the login, it gets into the login column. So the analysts know exactly where to look for data. If it is a laptop, I don't have to think that it is an IP form. I can always look it up, and that makes the data usable. The second thing is keeping data in the logic storage. With a lot of data, we want to normalize the data, which means we are changing the data, and something that seems unimportant is cut off, but this data may be important. And when there is an investigation, we want to get maximum data. Why do we keep the data in logic storage? Because the logic storage is the cheapest way to keep a lot of data. And the object storage. And then we want to make sure that analysts can find something there. All the data should be kept in the analytical database so that an analyst could get the information. It could be incidents, a response, or building other solutions. And the final thing that we have is sending all of those normalized data into the module of streaming, which works on identifying the incidents. And now let's talk about why Yandex Cloud and YDB are connected. I will give you a few numbers. Back in 2015, the YDB team was approached by the search portal. You all entered Yandex, and everyone sees a different start page. Yandex adapts this page for you, and this portal wants to make sure that this adaptation would happen really fast.
И как раз еще в 2015 году стало понятно, что
Once you do anything,
позволяет с нужной скоростью
it should be reflected in the start page. And the search portal should be adapted for your activities. And in YDB, we started doing this. And right now, it handles 80 gigabytes per second so that everyone has a Yandex of their own. When the guys approached us, they knew we had that, and they came to us with the numbers. It's 20 gigabytes of data per second. That's raw data they were getting at that time from all sources. After normalization, we have the flow of 600 megabytes per second. And with this, we have to identify if anything goes wrong. There are 120 rules for correlation to identify incidents, and still growing. And when we do normalization, like I said, we are trying to find some specific attributes, and now we have over 1,500 unique properties of data that we are using. And then it turned out that this whole system can be broken into three components. So the first one is object storage, because you cannot store data cheaper than that, than the CM, and it ensures all the processes.
Он есть внутри
Well, then it turned out that all this processing that CEM needs is already there. So the module of stream processing is the first thing. It has all the data that we need, and it also operates with the correlation rules. So when we thought about how to put it together, we had different variants. First, we wanted to create our own language that our security guys will write in. But then we kept thinking about it and understood that, yes, we can invent yet another SQL language, but there is standard COE 2016. And people already thought about that. And there is the complex event processing, and inside there is a match recognize command, so which allows you, by using standard SQL, to describe very difficult patterns, complex rather patterns, like stock quotes, security events, and so on and so forth. So we decided to take that in order to decrease the time we would need for learning all that. When we tried to see the amount of data, we have 600 megabytes, right, and several hundred rules of correlations. So 600 megabytes into each query will give us 120 gigabytes per second. And if we're going to scale, then we'll have a terabyte per second. This will be, we will become the largest streaming system in Russia, maybe not only in Russia. We didn't want to do that. Our task was different. So we started thinking how to actually decrease the amount of data that we transmit. And it looks like most rules of correlation do not need all the data. These rules do some kind of filtration and only keep the flow which they need. So we decided to automatize the filter use. So when the guys give us a query, they understand which data they need. So we go into filters, and as a result, the correlation rules only give us the data which we need. So right now we do not use more than 1.1 gigabyte per second, which is much more than what we could have used otherwise. So when we
when we transmit data over the flow module, it's important to see which data it is. If we see that the user Ivanov is using right now server number 1, if this is his personal server and he's working on it, that's good. But maybe it's a production critical server, and he shouldn't be there. So in order to understand what server 1 is, we use the specific component which is called lookup. So the flow system consult these lookups in order to understand what they are dealing with. When we launched the system, we understood that each second we are performing 50,000 queries towards lookups. First, we didn't know which system to use, but then we remember there is a prod system in YDB which actually can give you 1 million queries per second. And unexpectedly, we also saw that as it found out, the data has to be renewed transactionally, not only in the lookup. We haven't thought of that in the beginning, and we had some problems because there was a massive pressure on the catalogs and on the lookups. So this transactional renewal of data allowed us to avoid a lot of incidents. In order to understand how the flow systems work, there is a specific data bus line that is given to specific flow. We've had this data since 2015. We crossed them over, and it works well. The analytical database is needed so that SOC guys could consult this data in order to look for everything that they need. And on the one hand, it was important here that ADV can scale itself horizontally, because if we take 6,000 megabytes per second and multiply by 3 years, we'll have a lot of data. And the second part is it's important to work with a large number of columns. Just as all databases, initially we work with 100 and 200 columns. But when we normalize the data across all the sources, it turned out that we need 1,500 columns at the get-go, and preferably we should have 5,000, which became part of a problem because a lot of sources do not renew, do not update the data. Fire alarm, right? For instance, fire alarm maybe works only once a year, and there is, on the other hand, login and logout, which happens on a daily basis. So knowing that we have an event that is called fire alarm, and it takes more space than the data about the fire alarm. And we had to do a lot of optimization in order to learn how to work with such a great number of columns. Another thing, streaming without analytics is throwing your money to the wind. Why? Because the flow processing of data is about what's happening in the moment, here and now. You are writing a query in order to understand whether the sensors work, when the users are happy. When you work with this data, you only see what's going on in the present moment. And it can happen that some data you are only getting once a year because this specific server is turned on once a year. It's turned on, it transmits its data, it's turned off, and you're not ready for that, okay? So the ability to store data in the analytical database and use it for our correlation rules is very, very helpful. We will then be sure that everything works well throughout the year. This is a great function that helps us avoiding mistakes. And even if query doesn't work, you can always get back to the analytical database, have more tests, make sure that everything works well, and continue. The system of data storage has to be not only efficient, it has to be cheap, because if the database is quick, but if it costs like a space rocket, it will probably be changed. So one of the requirements that we had was to
was the push data into object storage that had to be transparent of the SOC for SOC analysts. They don't want to know where the data is. They want to send a query, get the results. That's it. And we're doing it with this transparent push into the cold data. The analysts notice that in some cases the data processing happens slower because sometimes we have to go to further removed DWH. The federated queues is something that we did not originally could make sense of. It's a federated query is a query that you can get with into any database. When the analysts started working with data, they realized that normalization doesn't always happen the way they want, or they wanted to get deeper, dig deeper in case of incidents. So they had to have an opportunity to get into the raw storage. So federated queries give them just that opportunity. Without leaving YDB, they can send their query and get everything that they need. So basically, this is where I wanted to stop. And as a conclusion, I will say, in order to launch SIEM YDB, you have to have a lot of data, databases, federated queries, and so on and so forth. All of these components already were in IDB. IDB is a system in in the making, so we are developing it all the time. My colleague told you about that, and that's what allows us to build, to construct such complex systems. Thank you very much. I'll be happy to answer any questions if you have them. Okay.
Говори.
Okay, go ahead.
Не слышно. Как-то не очень.
No sound, huh? There is no sound.
Попробуйте выключить, включить.
Try to turn off and turn on the mic. No.
Сейчас, подожди. Дадим
Okay.
шанс.
Give me just a second. Let's give Dmitry a chance.
Два вопроса. Первый, собственно, Павел Велихов.
Okay, I've got two questions. Pavel Velihov tells us that the latest research tells us that joint reordering is not needed. Yeah. You can just do it, send it to the production. Well, this is a difficult issue because there is some research about it, but okay, well, when we talk about large-scale analytical systems, we may have a large number of joins. And if we have to go through all of the tables and these joins, the numbers go ballistic. For 20 tables, there are about 400 billion of different variants. So everybody is looking for an algorithm in order not to go and sift through all of that. We are using one of the modern algorithms called dpHider. It's an optimizer which works on hypergraphs. And I think it's the 2017 model. There are two schools of thoughts about it. One of them says that these joins graphs can be simplified. And if you can basically streamline that into a line of strings, you can very quickly process that. The second school of thought says that indeed joins are not needed, are not necessary, but we still believe that the planning should be there, and we see that this is a good way to efficiently work with them. But when do we send it to the production? That was the main question. Okay, no, I understood. When does it go to the production? This summer. It'll go into production this summer. And it's important to note, I think, that these schools of thoughts that we've mentioned, they change all the time. Different research comes out. We analyze latest research all the time in order to see how to optimize what we've done.
So we keep working on it. Pavel Velikhov and his team are working on optimizing that. Okay, another question. Why is your columnar format of stories better than Parquet? And what inspired you to create it? I don't think we can say what's better and what's worse. Then why Parquet is no good. But Parquet is being kind of scaled down. Well, we have some computation in the memory. We don't want to convert them into the disk memory. Okay, so we have our own format. At the same time, we can go to Parquet. We'll read data from it, but we'll lose some power. No, I mean internal format. It doesn't look like anything like Parquet. No, it does not. It's our own. Because what we want to kind of save money on conversion. My first question is about the streaming service. Hold on. Why haven't you done many tables, but rather just did one and then have to kind of to press it down? Yes, we've discussed this. One of the options that we were thinking about is when events are going into the topics and then we read all of them. But this is very hard to manage because we have hundreds, if not thousands, of sources like that. And the SIEM guys said, no, let's just have one source. It will be easier for us to tap into that, and we will distribute the correlations rules. The second question is about the rules that SIEM formulates. Is this implemented in transfer mechanisms or somewhere in an outside system? Everything is implemented inside. We don't use outside systems. Why it was important? Well, we tried to decrease the number of spare parts. Since everything is in the same database, we can optimize the flows. What about the rules? The rules are also inside the database? Yeah. Oh, thank you. Hello. Traditionally, two small questions. You have all the set of means to control the streaming, and if we use yours, do we have to buy additional licenses? Do you mean if we take your things, do we have to buy any additional products? Yeah, if it's needed, or do you have kind of everything on board? And in YBD. Yes, everything is on board. Everything that we mentioned today. The SIEM system that Alexei referred to, it's all based on one product. We don't use any additional systems. At the same time, we have open interfaces. We are compatible with Kafka, for instance. And the data storage, some of it is in the cloud, others is... So how is this done? There are a lot of changes that have been introduced lately. IPM or cloud, yeah, so how does this work? If you want to develop a system, well, first of all, you have to understand where the safety perimeter within which the system can live. Right? You can have two-legged structure, one in the cloud, the others elsewhere, but there will be a certain lag of time. So when you build a system, you have to understand the kind of the time that is needed for communication between the nodes. Talking practically, if you have an organization, a company, and you understand which lags firewall will introduce, right? Then, of course, you develop the system, give it all that. It's better to do it on site, but kind of if you decide to do it in the cloud, do it in the cloud. But it's better to have it in one place rather than two places. Another question. Yes, question about the ownership cost. Since you have everything on board, including the streaming service, you hide this difficulty from your clients. But the system is difficult. There is a large number of things which will be in coercion. The difficulty doesn't go away, and I'd like to see what you think about that. Any system, even the simplest system can go wrong. Murphy law tells us this. This is an axiom. I don't think that we have to argue about that. You're right, though. The system is difficult. We hide this difficulty from our customers. However, the initial code is open. Talking practically, right? Because I think you were hinting about the empirical experience. No. What I want to get down to is who is going to repair if anything goes wrong. Well, it depends where it happens. On PM. Already today, we have a large number of installations that have been installed autonomously without our support. So I think there will be no difficulty in installing the system. Companies are big, but the specific people who are in charge of operating a specific program are really small, and I know that it works in practice. In order to do it easier, we did COS. We published it. I think there are a lot of questions that are answered there, and if you have more, please come to us, and we'll have support. If you're interested with interruptibility of business operations that is based on your databases, yes, come to us, we will support you. Thank you. Okay, a question on the other side of the room. I'm from the Voschod group. Thank you for your presentation. Quite impressed. I have a question which is down to earth compared to my colleagues' questions. During streaming, the logs are delivered in packages rather. When you normalize messages from that streaming, how do you work with an error? Let's say in a package, there are 1,000 different bad messages. Let's say 3 of them contain mistakes. What do you do with that? Do you sift for all 1,000? Well, there are different options, and this is not our solution. This is the systemic solution. The first option, if you find an error, stop. The maintenance guy will come to you and will take care of that. The second, throw away the errors to continue working, and the dead letter queue is the third one. So right now we pass the error messages because we have normalization systems that we trust. Why do we do that? Because as we found out, it's very hard in a big flow of data to find which messages have errors. SQL is not good at that. So we go to DL code. We understand that it's important. Well, we're planning to do it as the next step. And another question. Thank you for your presentation. It was very interesting. I have a question about federated queries. From the security point of view, when database sends a query to database, it's not always good. You use federated queries, or maybe there are some other means of communications between YDB and other DBMSs. What can increase the security level? Yes, again, you're right. Some time ago, inside the Parquet, we found a critical vulnerability that could attack the system that works with these files. We have the database with federated queries, and we have 2 options of working with outside data. The first is when YADB, its code, goes outside, gets the data, and starts working with them. And the second is when we have an outside server on the side, and it sends us the data. When we work with object storage, we go there with C++ code, because usually the object storage stores terabytes of data, and we cherish the possibility to process this efficiently. Other than that, indeed,
но у нас есть миллион различных процедур сертификации, аудита, сек-аудита, пентестов, которые все это проверяют. Но действительно уязвимости нулевого дня бывают, вот, и на нас они тоже влияют.
То есть, вот эта вторая история, которую вы сказали, это вот что-то типа шины данных, да?
Нет, второй гошный компонент или что?
Ну, то есть вот альтернатива прямым запросам.
Нет, это не шина данных.
Это внешний коннектор.
Это внешний компонент, мы его специально, то есть это внешний компонент, он написан на Go, у него есть интерфейс взаимодействия между самой базой данных и им. База данных ему дает команду: сходи туда-то, посчитай результаты, верни мне. И вот этот коннектор в этом случае выступает таким промежуточным звеном. Если что-то пойдет не так, то саму базу это не затронет, повлияет только на этот сервис.
То есть коннектор на отдельном сервере установлен, да?
Для построения коннекторов используются два подхода. Есть внутренние коннекторы и внешние. Мы практикуем оба. То есть внутренние и внешние коннекторы.
Спасибо.
И еще один вопрос успеваем.
Добрый день, спасибо. У меня близкий вопрос. Если ролевая модель, как она устроена, как мапится для сервисов и для пользователей, и как мапится от таблиц роль, привилегии на колоночные, и при хождении в другие сервисы, в другие хранилища при федеративных запросах.
Ролевая модель есть. То есть у нас есть группы пользователей, права достаточно гранулярные. Прав на ячейки пока нет. То есть вот то, что входит в понятие fine-grained access control, это в каких-то будущих релизах появится. Пока что права ограничиваются более верхнеуровневым объектом, это или таблица, или...
The rights are given for the object of a higher level directory. The rights can be very granular, all up to reading, renewal, deleting of a string. So, stemming from this model, you can put together the groups with different role users. If there is a topic that processes data and stores it for analysts, can you put additional limitations to that topic? No, not at the moment. Okay, thank you very much. Now, the traditional part of our conference, the best question. I think the question about federated queries. I have a different opinion, but okay. I will go with my choice. It's the federated queries question. Security of federated queries. Please come up. Thank you very much for your smart question. Guys, thank you for the presentation. It was very interesting. Don't go too far away. We'll have the next presentation in 4 minutes.
Меня... О, вот, слышно. Замечательно. Надеюсь, все вернулись. У нас еще один классный доклад от Саши. Тоже про базу данных.
I hope we're all here when we are now going to have the presentation from Alexandra. She also grew at Yandex, but she now works at Positive. Hi, everyone. Now let's continue with the products that started at Yandex, and let's talk about ClickHouse. But first, let's get to know each other, and I'll get a clicker. I'm Alexandra, or Sasha Popova. I have been in data for the past 10 years, and this was fintech and medtech and retail, and now I'm in info biz, and there were always interesting challenges there. What we are going to talk about the ClickHouse, a short intro in case somebody forgot or has never encountered that, so that we have at where ClickHouse can be slowed down and how you can help it and what are the alternatives. Let's get started. ClickHouse is the distributed system for database management for data analytics. It went open source in 2016, and it is famous for its fast, stable engines and much of that many like, and it all of those things make it stand out, really. And we know that it doesn't freeze. Where can ClickHouse be used? These four are taken from the ClickHouse website, where they say that it will feel great in real-time analytics, where we wanted to calculate something in real-time mode. Number two, classical storages, and once a day or several times a day, we get the batches of data, and we build reports, and this works. Then you can use it as data in machine learning as a source to calculate pre-aggregates, use them in models, or as the storage for the models. In the ClickHouse itself, there are several implemented predicative models, and if needed, you can calculate using them. And the last thing is observability, and today we are going to talk about observability, and we'll talk about how ClickHouse is experienced. What is observability? Observability has logs, metrics, and traces. And logs are text-based records of discrete events that occur within our system. For example, there is an alert, a mistake, and the data from the alert are the timestamp and the report about the event. The metrics. Metrics are numerical measurements collected from our system, and it indicates how it feels. What could be the metrics? Resource utilization, memory utilization, counters, gauges, histograms. When we collect them, if we have historical data in the future, we can understand what is a normal state of the system and what is the system degradation, and so respond to it. And there are also traces. Traces show the interaction between the components and how the query travels between the services. And this is super important and relevant. And those are records that track the journey of requests as they flow through distributed systems. There is a lot of data and still growing, and this has to do with the fact that the company is growing. We're adding new infrastructure and new apps. The company is growing, and so a lot of many metrics and traces are best when used together, when analyzed together. Now we can use to the main topic: how can you make ClickHouse slow down? A short intro. Now let's imagine we are a small company with an internal structure, and we are starting to put together logs and metrics and traces. We need to understand what's happening, and we choose ClickHouse because it looks good for our purposes. We read the documents and we study it, and we have a small cluster, and we think that it's clear about how the data increases. We will have the distributed click because we want to decouple the workload, and we started living with this. We started getting data. We have some analytics, but at some point we understand that we have predicted the data grows incorrectly. After 6 months, we want to grow. We want to add a new shard, and but we see that ClickHouse does not support automatic shard rebalancing. And sorry about that. Do something about that. What could we do? We could write something in a new shard, and this might result in a misbalance in workload, and it will not help with reallocating the data. We will get again to 85% utilization. Yet another shard. What else could we do? We could try to pull the partitions manually. We go have enough parts, and how many partitions, how much time, and how many tables, and do we have partitions there? And basically, you can have a framework on the top, and actually, this is what we did, and it is responsible for balancing the data. But it is about OpEx, and are we ready for that? Another thing to do, since we have a distributed click, we are using a distributed engine. On the side, we can export the data from the source cluster to the new cluster via add and search from select. This will not be performant on very large databases and will potentially incur significant I/O on the source cluster and use considerable network resources. And most likely we will do this successfully anyways, but we don't know when. But we need to analyze the data. What else could we do? ClickHouse has the TTL so that we can have the cold storage. We don't want to delete the data altogether. So what we could do, we could have the stream upload, but if an analyst comes over and says, I want to see the data for 2 months, and they launch this query, and on the one hand, the data from cold storage will have to be retrieved, and then probably we will not have enough space, ClickHouse, for this data, and everything will result in the manual work. And the next option is scaling vertically when it is possible, when you have unlimited resources, where you have petabytes of disks and petabytes. Petabytes on the disk and terabytes on the operational memory. And when we want to analyze all the data together, and when we want to find the traces, the events, study an incident, and we launch a query, and we start waiting, wait a little bit more, and we are not clear about how long we will wait and if we'll get the result. Why this happens? Because the soft join is an expensive operation, because for each value you will have to find the right value, and if the range is too big, then the computing complexity will be squared, and there will be competition for resources. Everything will be slowed down, and ClickHouse doesn't have inbuilt indices for join operations, and we have to think about what to do. ClickHouse likes wide data tables with logs, metrics, traces, and something else. But once again, this operation should come from the client. The client should write in a wide table. Another thing we could do, we can write our select using just one table. That's cool. But what are the other options? We could also use the materialized views, and you can do grab time-wise according to the metric we need. But we've got to remember that the math view can generate a lot of ports, and also to generate a lot of issues, because it is about generating ports, etc. We're going to talk about that. But we create this match view, and the only thing we'll have to do is to join according to the strict inequality. And after some time, we are saying we want to find something in the messages, and we launch this, and we find something. But we have to wait, because by default, this is a very expensive operation. And why so? Because we have to scan every line, which is very expensive. And the bigger the table gets, the longer it will take to search. And ClickHouse has a lot of stuff, and it has the experimental index. This is the implementation of the standardized inverted index. I don't know how to say that in Russian. They create a structure where for each token or engram next to it there is a position or where a certain word occurs. We create this index, but creating this index will slow down the inserts. And if we look at our CPU and our RAM, we will have to monitor them all the time, and slicing this into tokens and parts is very expensive. And this is an experimental thing starting from 2023, and Yandex wrote in their press release that they have to rewrite ClickHouse, and then it is a secondary index that ClickHouse will use only after it has used up the first ones, or you can also try and choose the Bloom filters. They exist in tokens, but this enables ClickHouse to skip partitions, but this is not a search according to a specific value, and Bloom filter will slow down our inserts, and it's not as fast as we want it to be. And now we are moving to the insert. We understand that we have a lot of data, and here is a little bit more about how the insert in the ClickHouse works. We have certain inserts, and ClickHouse puts all of that in the ports. Those are the sets of lines, and we have more and more ports, and the ClickHouse needs to merge the small files into big ones, and many people use that with Iceberg. And the merge is an expensive operation. Why so? Because you have to read the file again, and you have to do the decompression, then resort it, then compress and put it together. And if we have a lot of inserts, then we can run a mistake, which means that in each part of the table there are too many active parts, and this is what you get when there are 300. And for a ClickHouse, this is a way to say, now let's stop at that, now merge it, and then we'll continue. Right now I cannot do more than 300, and there are a lot of small files, and it always results to unoptimized reading, and there is always competition for resources. If we have something working on the background, what we could try doing, as ClickHouse recommends, inserts in batches anywhere from 10 to 100,000 entries. But if this is not possible, you can use a buffer engine. A buffer table is created in operational memory. It can keep the data and flush the data according to certain conditions, the timestamp and the number of entries, and it looks fine. But we also have to support the DDL of our destination and the buffer table. And if we add a new column, that's fine. The buffer table could insert the data in the overlap of the columns. But if we add team data, which is incompatible in the buffer table, and when we flush the data will be lost, and we will not even know that this has happened. Another interesting thing is that when we make a query to our target table, which is done by the buffer one. In the buffer tables, there are no indices, and if we have heavy
построчное сканирование данных, которые лежат в буфере.
Analytical queries, they might slow down if the buffer is not chosen optimally. This will be really noticeable. And you've got to remember that the buffer table is in a framework, and this should somehow help. And yet another point is that if anything happens with our node, then our data will be lost. And what is the alternative? In the ClickHouse, there are synchronous inserts as an alternative to buffer tables. We will not have to support DDL ourselves, but they work similarly. The buffer is done in the operational memory, and then all of it is flushed to a single part. But again, there can be a number of nuances. The data validation and data parsing happens at the flush stage, and the data might get lost. The same situation with an urgent
Опять же, может возникнуть ситуация
reload of our node, the data will be lost. And if an analyst creates a table where ourselves didn't do much thinking and chose the wrong key for partitioning, but anyways, we might run into too many parts error. So you have to be really cautious when you do the design. What else should we bear in mind? Cloud native, and let me explain what it is. The ClickHouse supports scaling, and horizontally you could add shards, but this is always manual work and operational costs. And in ClickHouse, there is replication. That's cool, and this is robust, but we have to support it manually. And if anything goes wrong, there is no self-healing. It can not heal itself or scale up. So we said that we should do it on our own. And another thing is that ClickHouse does not natively integrate into the cloud, and it's not so easy to deploy it in a cube. Yes, it can keep the data in the storages, but that's different. As to the cube, there is the ClickHouse operator, and there are a lot of bugs and issues, but still there is some progress. And this is my personal pain. Open source seldom has good information, but for the ClickHouse, they don't have different versions, and it's hard to understand the functionality for each version, and then you have to track it and somehow back engineer that. That's my personal headache. Now, moving on to the alternatives, what could you try to explore and use? Let's see what is available globally. There is Snowflake, Google, BigQuery, Databricks, Starbucks, a lot of things. But what's in common between them? If you look at the architecture, we're looking at Snowflake. It has separately query processing and data storage, same for BigQuery separately, and similar for Databricks. Compute and storage are separate, and all of this leads us to a change in the architecture. Right now, everything is moving
у тебя нода отвечает и за хранение.
From the shared nothing, when the node structure is responsible both for the storage and processing to the architecture where you have separately computing and storage. What could be the benefits? Number one, we don't have data redundancy because we do not support the replication the way we did in Data House. We can scale up flexibly. We can add as much as we need. We can allocate and distribute workload. We can select different engines for different workload, and this unties our hands in terms of choosing a technology. And thinking about what technologies could be in the stack. This is data storage, object storage. Then we select the file format to keep our data in. Then we need an abstract meta layer and the table format from which we could select something. Then we need a meta catalog to work with the data, and to download the data, we could use Spark Wing for analytics, Trino and Jupyter. There are more and more available technologies. And going back to the ClickHouse, actually they are trying to go into separating compute and storage, but you've got to understand when ClickHouse was created, it was about working with local disks and Merge 3 engines, and moving to a different architecture is really complicated. Right now, you could try to deploy this architecture when the disk is some object storage, and ClickHouse writes that you should think twice before doing this, and they suggest using the ClickHouse Cloud because there is an additional engine there, which is called Shared Merge 3, and it is available only there. And then what could be another nuance here, even if we deploy such an architecture, anyways, data upload would be slow, and some meta information anyways will be kept on ClickHouse's disks, such as indices. All of this will be kept on their disks. And then probably we could look at the cases about how the architecture changes. There is Influx DB. If you came across it, if you worked on graphs and various rows, and when this database came around, what happened? This was a monolith for storing and processing data, but then they decided to separate compute and storage, and compute for them is data fusion, and in the storage they have the data in Parquet. And the next case, which is very relevant for today, there is this company, CrowdStrike. It's an InfoBiz. Probably you heard about them back in 2024 when there was a huge Windows fuck-up because of the update of one of the products of CrowdStrike. But we are talking about a different thing, not the fuck-ups. In 2021, there was news that they were acquiring a startup called Humio. On the basis of this Humio, they created their own log-scale storage product, which is designed to analyze the logs, real-time analytics, etc. And here it would be interesting to look at the architecture. And here it exists through Humio, but there are nodes which are responsible for this, and there are data nodes that keep the operational information, and there is object storage too that we can use. And I believe it means that it's about separation again.
Okay, so the conclusions. The conclusions are presented as questions. ClickHouse is good, but it's only good when you can and want to use it. So before you switch to ClickHouse, please answer the next question. What is the amount of data that you plan to store? Do we need to scale? How quickly do we need to scale? What type of queries will be prevalent? Aggregation of data, filtration, difficult join operations? Maybe then we'll have to think about that, especially about types of filtration. Next question. Which requirements do we have towards the data and the speed? Or will it be in batches? Will it be streaming? And finally, do we have experience and resources to support ClickHouse in our team, in-house, so to speak? Well, that's it, basically. We've given it a thought, we've put our heads together, and that's the result. Thank you.
Что-то я задремал.
Спасибо.
I sort of fell asleep. Well, thank you for the compliment.
Из-за поезда.
Так, ну теперь вопросы.
Maybe because of the train. Okay, so now the questions.
Неужели
Questions?
нет вопросов?
I can't believe there are no questions.
Нет, на самом деле.
Oh, come on, you guys.
Было очень интересно, просто где-то в середине у меня начались общения.
Well, it was
Надеюсь, не алерт.
quite interesting. It's just that in the middle of your presentation, I switched to chat messaging. But anyway, I like the following part, that if one node not goes away, then we will lose the data. Is that based on the real events? Or? Yeah, it happened in my previous project. We used the buffer table, and we shouldn't have, because the ClickHouse doesn't like the buffer tables. The ClickHouse wants everybody to migrate to inserts, which actually can lose data as well. But yes, we did have incidents of that type. We have a question, I think. Женя, thank you.
Возились дальше, то есть пытались их оптимизировать каким-нибудь там.
Did you try to optimize the queries, the index queries? What? Partitioned one. Yeah, we partitioned that. We tried to do that. It speeds the process up.
Лучше не лезть. Особенно, когда у тебя много данных.
But if you have a lot of data, it's better not to risk it.
Да, просто когда там
we have the same issue.
много терабайтные таблицы.
If you have a multi-terabyte table, it hurts.
Еще
It hurts when it's lost.
Или опять мне спрашивать?
More questions, or should I ask one?
Ну, про потерю данных уже поговорили.
Okay, we talked about loss of data.
Вот там было про решардинг.
Could you tell us about resharding?
Не хотелось ли что-нибудь законтрибьютить для решардинга?
Did you want to contribute to that? It's very hard to contribute anything to ClickHouse. To write something of your own on top of it, yes, I think there is a need of that. if you are scaling all the time and if your ClickHouse grows. So this is something that you should do 100%.
Штуку осилить,
Если было бы просто, она бы
Do you think it's hard to do that? I don't think it's easy. I think if it were easy, it already would exist and would be available in open source. Did you try to do it yourself? No. No. I read an Uber write-up about that. They have an incredible ClickHouse installation, and they had to write something on top of it, and they spend a lot of time on that. And we're talking Uber, right? They have resources, right? And a lot of background and all that.
Ну, просто кажется, что вещь такая полезная.
Right. It looks like it's a very useful thing.
Странно, что
It looks like it should exist,
Ну, да, ClickHouse
but it doesn't.
Об этом
Well,
не сильно.
Yeah, ClickHouse doesn't want to talk about it about that, I think. At least they didn't think about it when they developed it.
Будем надеяться, что она появится.
All right. Well, let's hope that it will come into existence. Yes, it's open source. I talked about Google Query, Snowflakes. This is proprietary stuff. We have to understand that. And on the function that you have to do manually manually is done by a whole set of people. If you go to ClickHouse Cloud, it's pretty much automated. So it doesn't exist in ClickHouse Cloud either? No, I can't tell you right now. I don't think it is.
Еще один или первый?
Okay, if there are no questions, then Eugene will get the prize for the only question. What about yourself? I've already got one.
Вот он.
Oh, okay, here we go.
Подскажи, пожалуйста, вы
Thank you for your presentation.
данные или как-то их нормализуете?
Do you upload data into ClickHouse directly, or no? We only use ClickHouse right now for DB storage. So whatever you do goes directly into ClickHouse. Yes, it goes directly into it.
Возникают периодически всякие интересные истории именно с загрузкой.
Some issues are related to that about uploading to ClickHouse. The latest I recall, I think we didn't stay within memory limits. Yeah, but we could have tuned it.
В общем, загрузка в Click тоже интересная тема, про которую тоже можно еще.
Uploading into Click is an interesting subject. Ingesting, so to speak, I think we can talk separately about that some other time. Right you are. Okay. If that's that, another question? No. Good man.
Здрасте, спасибо за доклад. Меня зовут Илья.
Hi, thank you for your presentation. This is my question.
А был опыт вообще?
You were talking about ClickHouse and Kubernetes.
Или все-таки лучше на железках его?
Мы на железках всегда разворачивали.
Where do you host it? We host it on the hardware. And I think it's better to host it on hardware. My own experience tells me this. Everything that has to involve the disk, I would store that. I would implement that on the hard drive. I mean, on the hardware. I haven't seen ClickHouse and Kubers, but I think they're starting this. But personally, I don't know any companies where who have switched to Kubernetes. Yeah.
Кажется, что лучше, чтобы она была условно с data locality, да, чтобы данные.
Yeah, I think if you are using the disk a lot, the data has to be close to the computer.
Кажется, что с диском.
It has to be local. Yeah, I think it has more sense. I agree.
Так.
Давай.
Есть опыт?
Я не
Okay.
коллегу. В Linux, ну,
In Linux,
что кему там виртуальная машина, что у вас железо.
container in Linux is, it's just.
Грубо говоря, все на одном хосте, все рядом.
Прекрасно. И у вас это просто процесс. Ну что,
It's just for comfort, but Camu or Containerd, they're all processors.
Ничего почти не тратят. Это ошибка.
They don't use much power.
Разворачивание, фактически администрирование.
Well, basically, the comfort of administrating.
С одного хоста, ну.
That's what we have, because it's very hard.
Вы не выиграете, или я не прав?
I mean, if you have Kuber,
Тут нужен DevOps.
you will not
Как масштабировать клик?
gain anything if you try to scale a host from one host. Hi, my name is Sergey. I want to join this conversation.
Мы в разработке антифрода занимаемся.
I work in F6. We actually have ClickHouse in Kuber.
Скажем так, мы столкнулись
And how is it going?
с проблемами, которые здесь перечислены.
Well, actually, we've encountered all problems that you enumerated. How to scale it? Yeah. We're doing it in batches. Analytical queries, yes, but scalability is a big problem. So, we still don't know how to do it. And as I understood, there is no solution on the market. I was interested in object storage. Are we talking about remote S3 storage, where the computer basically deposits data? Oh, yeah. Yeah, it's an S3. It doesn't have to be remote. It has to be in your system, but it's got to be in object storage. But then again, we have overhead. We do have overhead, but for cold data, I think this overhead is allowable. Okay, so store the data which you don't need for hot queries, right? Something historic, right? Yeah, historic, or if you have a raw layer, you don't touch it very often, neither do your users, but you don't want to lose it, and you want to save on its storage. You can, I think, store it coldly. Well, if you look at what ClickHouse says, that there is a node for computer, there is a node for this and node for that, and it doesn't matter how often you use data, they are all placed into object storage. There are specific drivers or specific engines which can work with them quicker. It's not like I think it has better response times. They do try to make it quicker. They have an additional driver that allows you to work with metadata and with S3. So it'll go a little quicker than just dropping it into the cold storage and then going back. On the computer nodes, yes, you can cache, you can implement some data prints, right? And talking about the nodes, we also store meta information there, indexes or other structures, keys. Is there an example of practical use of that I could read about? I think ClickHouse provides some examples. I don't remember the company off the top of my head, but I think they only have one case to date. Okay, thank you very much. I liked your presentation a lot. Number of memes for me is the quality factor. Hi, thank you for your presentation. My name is Victor. I have a provocative question, I think.
Ваш ClickHouse положить некорректной TDL-кой.
Have you tried to basically to drop your ClickHouse with an incorrect query, the query which was incorrect by default? Yeah, well, because we could kill a node. No, the whole cluster. The whole cluster, no. But the node, yes. One incorrectly formulated query and off goes the node. Okay, I trust you. Thank you. More questions?
Ну, теперь есть из чего выбрать.
Да, вот.
Okay, now you can choose from.
Даже не вопрос, а просто сама ситуация, что вот у ребят развернуто.
I like the situation, not so much the question, but the guys implemented not ClickHouse in Kuber, and I think the price should go there.
А книжка у нас, да?
The prize should go there. Do we have a book to give? Who asked about ClickHouse and Kubernetes? Thank you very much.
Тогда еще через 15 минут следующий доклад.
Okay, with this, we'll have a small break, and we're waiting for everybody in 15 minutes. Okay, the next presentation will be about SRE. Thank you. It was great.
еще есть силы послушать еще один крутой доклад. И у нас финальный доклад. Артем расскажет.
Now we have the final presentation about SRE in data, and now over to Artyom Shepelov. Okay, cool. The speaker is off the mic. The speaker is off the mic.
Я занимаюсь надежностью примерно с 2015 года.
I have been in reliability for 15 years, and I started working with reliability, DevOps, and I did the first operational platform that did metrics and alerts for our DevOps and SRE, and then I also worked on SRE and DevOps, and I have been helping the analytics and engineers to feel more confident and to use the practices that exist in SRE, that is site reliability engineering. Why are we talking about three spiders? I love this picture. And when I started doing data, it often occurred in our communication and finding who is responsible, who should do things. That's very appropriate in data, because usually there are a lot of teams and people who are responsible. And before we get started, I would like to introduce a few things. There is this thing called the criticality metrics, and this is the global benchmark, and the highest criticality is for the services where you can face the biggest losses, that is in IT, the work of the payments, ATMs. In data, most of the time we don't have such representatives. And first, the non-availability of data can hardly result in really high losses. And the requirements that we have to the availability of data, the ability to restore the data and to respond for data is not really applicable. But in business critical, we already have the representatives like that. In IT, for example, this is loan origination, building and ETL storage, and in data, it is the regulation just in time. And below, there is business operational, the work of Jira, Wiki, HR platform, CRM systems. And in data, we are talking about all sorts of operational analytics and managerial reporting. In office productivity, this is about the work of AI assistants, 5 letters application, the availability of data front stores for the business analytics. And I would also like to do certain parallels with SRE. And here I show a classical tandem. And this is the team that is in charge of storage, that is in charge of the network. There are platform services, the virtual machines, and different environments, and classical database services, and the development teams built their own applications to interact with the users and clients. We have applications of a different level of criticality, and in case of SRE, the criticality is inherited downwards. If something is unavailable, then it will be available for all the application series. It will be unavailable irrespective of their criticality. And how does it work in data? The data is taken from the operational databases through certain processes. They are delivered to the storage. In the storage, then everything is taken by the data engineers, and they do the ETL showcases, and this is how the compliance procedures and other processes for data are built. And in a similar way, we get the supercritical reports that we have to send to the central bank today. And there are others which are not that critical, but you still have to keep them. And so the criticality is there for the down layers, but it doesn't work upwards the extracting block is shared, and it is the most critical. But if you look at the ETL and analytical domains, we cannot require the criticality from the ETL piece underpinning the non-critical reports. And to get even more immersed into this, I would like to show examples of certain incidents in data. For example, we did not have an update of raw data from the application, which means we will not be able to get fresh data, relevant data, which can be used in the new fresh report. Another most terrible example, when the extraction of data doesn't work at all, we don't get it either in ETL or analytics domains. And an isolated small example where the ETL models didn't work, and this only influences the analytical domain that uses this. And I would like to talk a little bit more about the detailed showcase of an incident to understand the problems we are dealing with. The trigger was that the users saw some outdated data, and the analysts start looking at the issue. Where was the data lost? They do test inquiries. They write to the help desk to identify where the issue really happened. And the others don't really understand how critical this is and how much time they have to resolve this. And they don't understand who else was affected. And to answer these questions, we launched the process of data instinct management, and it has to identify the incidents and note the criticality. To understand how it works, I will draw a mind map with the key points. First of all is the criticality metrics and the data lineage, the hierarchy of dependencies, of attributes. Then this is what the data pipeline looks like, and how these accountable people can then use that accountability and access, and we'll see the indicators of inaccessibility, and we'll see how it builds into the overall platform solutions. Here, let me remind you that we lack processors with maximum criticality, but business critical, and below level abounds in them. Let's have a look at what the data lineage, just in case, let me show that schematically. Imagine we have some raw data spreadsheets in our storage, and we use these tables to build ETL domains. And on the basis of these ETL domains, we built the analytics. And lineage gives us a lot of useful things, such as the impact analysis, migration processes. We use that in troubleshooting and incident management. Let's try to work on this horizontally and see the participants and joins. And this is delivered to the storage. Then this raw data is taken by the data engineers, and they turn it into the ETL domains and model data. Then the analysts use laptops and bioinstruments to turn that into reports, dashboards, etc. And they can also use that in the operational environment. And this is consumed by compliance and by the users if it's operational data. Who are the main actors there? It's the team, data engineers, and analysts. And how do they agree about how to use the data? Let's remember the same thing. We have a supercritical process, and it's very important to have high availability so that the down layers could respond fast. They talk to the data engineers, and they explain why the report is important and what risks will realize if the report is related. And they agree about the level of criticality. But this is obviously not enough, because there is also raw data at the bottom. So they talk also to the vendors, to the contractors, to the providers, and they increase or raise the criticality of supplies. And where do we need the criticality notion? I tried to explain that in high-level groups, because a lot of important activities didn't start because we were in a deadlock. We said we didn't know what is critical, and criticality opens a lot of doors. This is an artifact for the criticality of bottom layers. This is the prioritization. If there is a failure or degradation, the right identification of the level of failure and escalation, also identifying the requirements to the team and how they should respond, the help with the filtration in migration, and why we have to migrate data, etc., forming best practices to identify mismatches and discrepancies. Also, filtration organization. We have to respond first to what is supercritical. What is not critical might have different quality of service policies. And it's about the exact understanding by the business, the criticality of the
это там
processes.
одна из ключевых.
And let's talk about service level indicators. This is one of the key things in SRE, automatic and fast in real time. We should understand if everything works. And in data, we have these examples. For example, the readiness of data by a certain time, the relevance of data, and also taking the data through certain checks, and we might have an integral indicator which should be above a certain percentage. And to come up with the high-quality indicators, we also ask for deadlines, and for ourselves, we have the soft deadlines and hard deadlines. And if we don't get that right, the risks will be realized. And why this is important? Because the processes that are written on paper are hard to follow, but when there are certain platform and not just platform solutions, you can improve your process and product through the integration. For us, this is about such services. If all the further described services are internally developed by NT, and they are a platform product. That's our flagship product, FindDog. This keeps the status of incidents, the mapping of who is responsible for what. We work with the alerts, subscriptions, etc. And then our platform, observability platform, Sage, is about metrics, logs, tracing, and alerts. It's also about a data quality platform so that we get the results of quality checks fast. And then we also have the data detective, and we show the key attributes when they're needed. And we also get the data lineage. Without that, a lot of features would be impossible. And there is also the tool that is called Severity for calculating the readiness by the time. And let's look back at the scenario I showed at the beginning, and let's see what really changed. The analysts look at the issue, and now they have the lineage. And now we know for sure who is responsible for what. And thanks to that, whoever is responsible has the responsible person, the accountable person. And so we can say very clearly when the issue occurred. And we also have the criticality, we have the failure, and we have the color for the impact, and we also have the deadlines. And because of the availability of the lineage, we can use this data and we can understand who else was affected and include them in the total picture of a failure. And this riddle of the three spiders is close to being resolved. And I would like to show you a few metrics. And what we do is
полностью запущенным процессом этой штукой чуть примерно полгода.
We have been working with this thing for 6 months, and we and around 20% of our critical processes, and the usage of lineage covers 4% of all the spreadsheets, including Sandbox, and 15% of the total product perimeter. And 2 out of 3 processes have an incident. And sometimes it's more, sometimes it's less. And it might seem that we are not stable and we have a lot of incidents. But for us, this is a very positive signal, which shows that we can see the failures, and because we see them, everyone affected learns about them at the right time. And we also get in the position to analyze what is happening, finding the system insights, and work on making sure that these system errors do not occur again. Apart from that, there is a high conversion of alerts in incidents, 6%. This is achieved because we are able to
тонко подобрали индикаторы, которые
select the indicators in a subtle manner and fine-tune them. So we have
процессом, который мы им дали.
false positive results really seldom, and we have 100% filling in of post-analysis and post-mortems for critical incidents. That's important to capture our experience and making sure we do not repeat that. So what have we learned? We have learned what is the criticality of data, why we need the lineage, and what does the data pipeline look like, or what are the participants, how these participants can agree about criticality and use it, what are the indicators of data reliability, and why this needs to be part of the platform services. Most of the materials in this presentation are based on the analog Unitro. Unitro is a freely available program, so you can ask me questions if you like. Okay, now over to your questions. It would be interesting to know the real time for responding to incidents in terms of those on duty. How many hours? You mean the response time? What is your SLA, roughly? Now, look. We have a different matrix. I didn't show it here, which identifies the different levels of criticality and the recommended response times. And for the most critical, it is within an hour. For the least critical, for the least critical is around a week. And this is something where we say no criticality, and office productivity is 1 day, 1 work day. The minimum is 1 hour. And it's interesting in terms of operational management, how do you appoint those on duty? So you have the data engineers who are on duty to respond to incidents, or everyone has their own time or their own area that they have to respond to. So we entered in the overall platform solution for incident management, and we have quite mature practices for SRI, and we have the institution of being on duty, and also those shifts And we just reused this approach. We identified all the levels of this cake. We made sure that they have their teams there, and they should create the calendars of being on duty. And in particular, we make sure that people rotate. So data engineers have a certain schedule. So even if some critical dashboard falls, they will not have to step in. I didn't quite get it. In this case, SRI, data engineers are the developers. Most of the time, they do the analysis and they develop things and they make models, but they're also responsible for the reliability of what they do. Not everyone has them dedicated SRE, because if you look at ordinary, usually they have people for monitoring the reliability alerts, metrics, etc. There are processes where we have the dedicated teams, but generally speaking, everyone is responsible for their own piece. And from my experience, yes, data engineers have time on duty, and this is a normal practice. This is a normal business practice. Artem, thank you very much. My name is Evgeny, and I have this question. You said there was this incident when users identified a problem with the report. When was it? 5 years ago when you started to work? And why no other alerts work? You have a very long chain from raw data to data transfer. Why no other alert worked? So why did it get to the users? And then you get into the ETL platform and it got to the users. Thanks for this question. So the generic answer is the same as SRE approach. Working with alerts is the continuous work. You identify an issue, you insert an alert, then there is a new issue arising and you install a new alert. For that issue, there was no alert, but then a lot of people overlooked that. SREs who didn't check their data, engineers didn't or did not validate this. Yeah, it was a comprehensive issue. Yeah, exactly. And within this activity that we are doing, this whole progress bar for critical processes, the next stage will be that we will look at those critical processes and we will say, guys, if you are down, let's have a look at what we could do about that. And we need to make sure that they can respond fast if they see issues with the business logic or they don't get. If no one else has questions, here is mine. And twice you mentioned that an analyst does the incident decomposition. I always had an issue in my company. The analysts sometimes lack competencies because an analyst most of the time is a smart employee who puts together light, easy queries for the needs of the customer, and the developers and the data engineers are saying, oh, go ask somebody else. It's not my problem. That's very true. How do I best answer? Here, I will just try to show you something to you. Do you believe that this is the task of an analyst? Should an analyst do that? To demonstrate that, I want to show a specific case to you.
Вот, в общем, смотри, вот на самом деле аналитика вот здесь, им прежде
Now
всего
look,
надо взаимодействовать
the analysts first and foremost have to interact with their data engineers. Like you said, they definitely don't know it all, and not always will they be able to tackle the incident, but they have this first hop, and if they have a massive issue and they don't see it on their side, then data engineers can interact with the platform, with the supplies, and they have a lot more contacts. They understand what it looks like from the inside and where something could go wrong. This is just one of the underflows in the incident process. These groups interact layer by layer because this is something they know better. And for us, the analysts would run to the developers of the products and they said, this is your issue, and this was better and more successful because most of the time the analysts work with the developer so that we know how to tackle the issue. And the data engineers were outcast somehow. They were the fifth wheel. And the analysts are the people who use the fruits of the labor of the data engineers. Okay. Any further questions?
No.
I'm still here.
Такая интересная тема.
Such an exciting topic, guys. And no questions? Are you serious?
Вопрос не ответил. Когда это была проблема? В начале твоей карьеры?
And you haven't answered my first question. When did this happen? Was it 6 months ago or at the beginning of your career? I believe it was last autumn. Actually, this case is not completely from real life. And the key issue had to do with the fact that the unavailability of data, it wasn't obvious that it influenced something critical, and so they didn't really rush to fix it. Okay, it looks like there are no further questions. Artyom, what was the best question of the two?
Что?
What?
Ну...
Okay.
Да.
Можно книжечку?
Can we award a prize to this gentleman? Okay, Artyom, thank you very much. It was interesting to look back at what it was like. Okay, thank you very much. Thank you. Thanks a lot.
Всем спасибо, что послушали. Надеюсь,
thanks a lot for being with us. Hopefully it was useful for you. We're finishing off this track, and hopefully the other tracks will be just as interesting, and you will come and listen to those too. Thank you.